yours truly, the Institute for Engineering Research and Publication, also known as the IFERP. Just a little bit about us. Institute for Engineering Research and Publication, or IFERP, is one of the world's largest non-profitable professional associations meant for research development and promotion in the field of engineering and technology. We are a platform to promote the advancement and dissemination of the knowledge of engineering and technology. IFERP is a professional association and a forum where innovations and research interests could be supported and developed, prioritizing our mutual interest. Our forums and associates constitutes professional leaders and organizations, connecting each other with a mission to work as wizards of science for defending the earth. IFERP provides a world-class platform for scientists, researchers, academicians, business figures by organizing conferences and publishing research articles. IFERP conferences bring together the professional wizards and leaders who have explored all avenues to reinforce the field of applied science, engineering, and technology. And of course, one of the organizers, Vishwaniketan, is poised to become one of the leading institutions in India in our quest to achieve a new milestone in undergraduate engineering education. We have come together as a group of extraordinary educationists, corporates, industrialists, and entrepreneurs. We are not only part theoretical knowledge, but also introduce our students to real-world problems that they face when they join the industry. Vishwaniketan's Institute of Management, Entrepreneurship, and Engineering Technology, or the VMET, is approved by All India Council for Teaching Education, New Delhi, HRD Ministry and Government of India. It is affiliated to Mumbai University. The search results are CTIF Global Capsule, also known as the CGC. Vishwaniketan Network is responsible for our collaboration abroad and in India. VMeet is already working with academic partners such as Oracle Workforce Development Program, or the WDP, IBM, and ZenSAR. The Vishwaniketan CGC network has created opportunities of summer internships, master's, and PhD programs for Indian students and teachers in universities abroad. In the last 7 years, the network created 25 plus tie-ups with universities abroad. More than 900 plus students have successfully completed PBL summer internships, UG fellowship, and more than 70 teachers completed PhD. Here's a short video about our organizer.
Do you want to experience the best innovative approach in learning? Vishwaniketan is the first private engineering institute in India to implement project-based learning, that is PBL, a methodology that effectively bridges the gap between theoretical and practical education. Students with less practical knowledge often find it difficult to cope with the new industry challenges. To address these issues, Vishwaniketan introduced summer training programs for 7 weeks in Europe and US universities, followed by masters for students. With robust PBL, students now have the opportunity to learn architecture, engineering, design, business modeling, and incubation together under one roof. Vishwaniketan's impetus on practical knowledge led to the creation of the best industry labs through collaborations with the best foreign universities, including a state-of-the-art business lab by Aarhus University, Denmark. The efforts have paid off with 86% placements and 100% industry internship achieved. Young founders were born with 14 student-founded startups formed due to the help of Vishwaniketan's Incubation Center. with safe hostel and transport facilities at Khalapur, near Navi Mumbai. Boost your future by visiting www.theidy.com/Vishwaniketan campus or call on 86988 79633.
All right, and just a little bit about the conference. The objective of this conference is to present the latest research and results of scientists, preferred students, postgraduate students, research scholars, and postdoc scientists related to electrical, electronics, and communications engineering, and computer science and engineering. The conference will feature traditional paper presentation as well as keynote speeches by prominent speakers who will focus on related state-of-the-art technologies in the areas of the conference. The aim of this conference is to assemble scholars from all over the world to present advances in the appropriate fields and to foster an environment conducive to exchanging ideas and information. This conference will also present an ideal environment to extend new collaborations and gather experts on the fundamentals, applications, and products of the mentioned domain of computer science, information technology, electrical, electronics, and communications engineering with valuable discussions in order to make the outcomes more realistic. The benefits to delegates attending this conference are the following: learning new ideas and approaches in conferences make delegates more effective and efficient at work. Conferences offer the opportunity to delegates to meet business leaders and to position as an expert in his or her field. Good conferences offer the opportunity for delegates to mix and mingle, form new relationships, and strengthen existing ones. A well-run conference will help faculty curate new ideas. Even though there is a lot of information on the web, conferences will cut through the clutter to deliver the best content specific. Conferences force the delegates to break out of their comfort zone. Breaking out of comfort zone is just the type of action that is necessary to break out of old ways of thinking. The flip side of learning new things is relearning classic techniques. Conferences create opportunities for greater focus and reflection that could help delegates to take ideas to the next level. Conferences provide a unique convergence of networking, learning, and fun into a single package. And now, guys, I would like to welcome all our honorable dignitaries. First, let us welcome my beloved Principal Dr. B.R. Patil, Vishwaniketan's Institute of Management, Entrepreneurship, and Engineering Technology. Next, the Vice Principal, Professor Shankar B. Kadam, Vishwaniketan's Institute of Management, Entrepreneurship, and Engineering Technology. And also, I would like to welcome beloved conveners of our conference, Professor Kishore Mane or Main, Assistant Professor, Vishwaniketan's Institute of Management, Entrepreneurship, and Engineering Technology. Next, Professor Chinmay Rohikar, Assistant Professor, Vishwaniketan Institute of Management, Entrepreneurship, and Engineering Technology, or the VMET. Professor Sagar Dotare, Assistant Professor, Vishwaniketan's Institute of Management, Entrepreneurship, and Engineering Technology. Next, I would like to welcome our eminent keynote speakers for this conference. We have three. Dr. Andy Morale Varaprasad, Professor and Director CIGS at St. Anne's Engineering College, Chirala, ex-DRDO scientist. Dr. Madi Karkush, PhD, Professor of Civil Geotechnical Engineering, University of Baghdad, President of Iraqi Geotechnic Society, Iraq. Professor Dr. Dilip Kumar M., Director, Professor, NFCT, Malaysia, and Pro Vice Chancellor, Academic Research, GNS University, India. Next, I would like also to welcome our session chairs for our conference. Mr. M. Subash, Associate Professor, Civil Engineering, Guru Nanak Institute of Technology, Ibrahim Patnam, RR District, Hyderabad. Next, Dr. M. Mahabub Basha, Professor Electronics and Communications Engineering, Srinidhi Institute of Science and Technology, Hyderabad. Next, Professor Mrs. Rashmi Nayak, Professor and Head of Department, Sandeep Institute of Engineering and Management, Nashik. Thank you all for joining us even during this pandemic situation and imparting your expertise. And I would like also to welcome all our presenters from all over the world who have shared their valuable ideas and innovation for this forum. Now it's my immense pleasure to welcome to deliver a speech. He is currently the principal at Vishwaniketan's Institute of Management, Entrepreneurship and Engineering Technology, or the VMET, Mumbai, India. A PhD in Electrical Engineering from Baba Atomic Research Center, PhD Center, University of Mumbai. He has 4 years of industrial experience and 23 years of experience in teaching engineering students and training industrial employees. His fields of interest are biomedical engineering, electrical engineering, and nuclear instrumentation. In research work, he has developed a low-cost, simple, and safe method for diagnosis of osteoporosis, which was commercialized by Baba Atomic Research Center, or the BARC, in Mumbai, India. He is deeply interested in problem-based learning activities involving user industry. He is engaged currently to support Vishwaniketans to develop Engineering College Center for PBL Excellence in India and Incubation Center. He has been chairman, Board of Studies in Electrical Engineering, University of Mumbai. He also worked as a member of various authorities and boards at university level, such as Academic Council, Faculty of Technology, Research and Recognition Committee, Board of University Teaching and Research, and also Standing Committee, etc. He has worked as expert committee member of universities, state government on education, quality assessment, and the same. He has been actively involved in manpower development programs in industries like Reliance, Indian Petrochemical Limited, etc. He has published many papers in international journals. He is an author of a popular textbook, Basic Electrical and Electronics Engineering, published by Oxford University Press, London. Sir, we request to deliver welcome address about the conference. Let us welcome Dr. B.R. Patil. Morning, sir.
Yes, thank you, madam, for your nice introduction. So, am I audible, madam?
Yes, you are. It's our pleasure, sir. Go ahead.
Thank you. So, good morning to all of you. Now, it's my great privilege and honor to be here on the second day of this conference. Dear colleagues, professors, teachers, researchers, ladies and gentlemen, on behalf of Vishwaniketan, so Institute of Management, Entrepreneurship and Engineering Technology, that is BIMET, I would like to express my sincere gratitude, and with great joy and pride, I welcome to all of you on the second day of this international conference, virtual conference on innovation challenges and advances in engineering and technology 2021, that is ICAET. So moreover, I honorably welcome our today's keynote speakers, Dr. Andy Murli, who is an ex-DRDO scientist. Second, our keynote speaker, Dr. Mahdi Karkush, who is a professor of civil geotechnical engineering, University of Baghdad, and president of Iraqi Geotechnic Society, Iraq. And third one, Professor Dr. Dilip Kumariam, director and professor, NFCT Malaysia. and Pro Vice Chancellor of Academic and Research, JNS University, India. So, as the principal of this institute, I consider myself very fortunate and privileged to be part of this educational institute where everyone, including our professors, staff, and stakeholders, worked and contributed to the humanity through this online gathering despite of this global pandemic. Everyone know the theme of this conference, that is innovation challenges and advances in engineering and technology. That is a road to self-reliant India. That is Atmanirbhar Bharat. Okay, we used to talk about this word normally, but you know the current scenario in India, almost 70 to 80% products and technology we are importing at present. So still we are developing countries. We need to create more and more products. We need to create more and more technologies. So as we know, who will create this? Obviously engineers. So obviously engineering institute has a significant role to play in achieving this aim, means aim of self-reliant India. So we need to create a proper ecosystem to inculcate the research culture in institute. Also, we need to support and encourage the research. We need to create proper platform for researchers to engage and exchange their ideas, their findings, and definitely the virtual conference like this will be helpful for fulfilling these needs. So I'm very happy and thrilled to see the response of researchers to this international conference. I came to know that the conference has received 89 papers from all corner of the nation. Out of these, 52 papers have been accepted by the committee for presentations, and which are included in the conference proceeding. The proceeding has been meticulously documented and will be valuable resource for researchers. All papers which when selected for the presentations will have the opportunity to be published in the reputed journals. And it is pleasing to note that the agenda of the conference covers a wide range of interesting topics related to all theoretical and practical aspects, including the latest trends in computer and science engineering, information technology, electronics and communication engineering, electrical and instrumentation engineering, mechanical and production engineering. Apart from these, teaching methods and pedagogy, business modeling, and startup challenges. So, and about this conference, just I would like to mention over that this conference would not have happened without the dedication and tireless efforts of organizing team. So I extend my sincere regards to the all keynote speakers and all the chairpersons for giving their perspectives on current research themes. To all the members of the organizing committee, the International Scientific Committee, the reviewers, and the collaborative partners, I would like to thank all of them for their tremendous efforts to organize this conference successfully. You know that this conference is being held in association with the Institute for Engineering Research and Publications, that is IFERP, which is continuously working on the theme of connecting engineers and developing research. I would also like to express my gratitude to the IFERP team for their assistance in organizing this event. May God bless us all with good health to make this event a successful and enjoyable one. With my best wishes, thank you very much. Over to organizers.
Thank you so much, Professor.
Thank you, madam. Thank you.
And now Thank you so much for that speech. And it's also my immense pleasure to welcome um, a professor and director at CIGS, St. Anne's Engineering College, Chirala, ex-DRDO scientist. Earned his PhD in 1979 from IIT Bombay on piezoelectric sonar technology, followed by 3 years of postdoctoral research experience at Microelectronics and Electrical Engineering Department of Trinity College, Dublin, Ireland. Dr. is a reputed DRDO scientist with 3 decades of experience in the field of missile technology at Research Center Emirat, or RCI, located at Hyderabad. RCI is the brainchild of Dr. APJ Abdul Kalam and specializes in avionics, navigation systems, control systems, radar systems for Agni, Prithvi, Danish, and air defense AD missiles. Doctor has been awarded Japan Matsumai International Foundation Medal in 1987 and Materials Research Society of India, or MRSI Medal, in 1990. Other notable contributions of the doctor include piezoelectric sonar systems for Indian Navy while working at NMRL Mumbai during 1984 to 1988. Before moving over to RCI Hyderabad, Dr. Varaprasad served DRDO for 28 years and retired from DRDO services in 2012. Presently, Dr. Varaprasad is professor of ECE department at St. Anne's College of Engineering Technology, JNT University, Kakinada, involved in teaching and research on satellite systems. Sir, we request to deliver keynote address to the conference. Let us welcome Dr. Andy Murali Varaprasad. Morning. Good morning, sir. Good morning, doctor. You're on mute. Hi, good morning. Yes.
Okay. Very nice. First, should I start the lecture now?
Go ahead, sir. Please proceed.
Okay. First of all, I am very thankful to Dr. Patil sir for giving me the introduction about me, and yourself also. You have read about the biodata very nicely. So actually, the topic that I have chosen for today's talk is space science and technologies, advances in the space science and technologies. In fact, in colleges, we really don't have many subjects are in the branches. See, in my college, in electronics and communication, there is one satellite communication subject. Apart from that, there is no other. That is also elective. That is also elective. Now I will go to the presentation. That will be, may I share my slides?
Go ahead, Professor.
Okay. Am I able to share it? Hello?
Not yet. Not yet.
Not yet. How to share the screen? Okay. How to share it? Share screen.
Yes. When you click on share screen, Professor, you will see there a There will be a screen that will pop up. Please make sure to choose the PowerPoint presentation before you click on share.
Okay, this is my PowerPoint presentation. Okay.
There you go.
Yes, yes.
There it is.
Yes. Yeah, we are able to get it. Now, this is the introduction slide about our engineering college, Vishwaniketan Engineering College, and then management also they are teaching. Very good, very good. Dr. Patil sir has given very good briefing about the college also. The topic is name I have chosen Advances in Space Science and Technologies. I actually belong to DRDO. After retirement in 2012, I joined this St. Anne's College of Engineering and Technology. Here you see I am the director of Center for ISRO GNSS Studies. This word ISRO GNSS is referring to actually Indian GPS. Indian ISRO GPS. GNSS is actually GPS only. GPS is a word registered by the United States, so we cannot use that word that much. So GPS, Indian GPS. So today you will be able to find a lot of improvement in our Indian scenario by having Indian own GPS. This has started in mobiles last year, but it has not yet become so popular. But I hope in future it will become very much popular. So around 2,000 rupees extra you have to put for the GPS plus Navic, we call it Navic. That is navigation with the Indian constellation of satellites. I will go through that in the few future slides. I request you to note down one thing. Here my mail ID, amvaraprasad@gmail.com. This mail ID, if you is a connection, whenever you need any information, not only for this conference, but in general also, you can approach me through this mail ID. Have you noted down? Please note down my mail ID, amvaraprasad@gmail.com. This is for our future contact. Now I will go to the first slide. Yes. This is a very interesting slide. You know, on 11th May 1998, we have done that Operation Shakti. Operation Shakti. And this is Kalam sir in the army uniform. This is chief of our Department of Atomic Energy. His name is Dr. R. Chidambaram. So chief of DRDO and chief of the Chief of Atomic Energy Commission. Both of them were involved in doing this very highly secretive work, and they have actually done it so much. They got the name of nation has been on the United in the world. Okay, now I want to go first to pay my respects to him and to contribute to this. His name, he wanted to make the India the developed nation in his lifetime. It has still a dream. So I want to read what he has got the message. My message, Dr. Kalam's message, especially to young people, is to have courage. Is to have courage to think differently. Courage to think differently. Courage to invent. Courage to travel the unexplored paths. Courage to discover the impossible and to conquer the problems and succeed. And to conquer the problems and succeed. Problems will always be there. You have to conquer the problems, the courage, and then succeed. These are the great qualities that they must work towards, the youth of India. This is my message to the young people of India. That's what he said. So remember that, and you also take a pledge. As the youth of my nation, I will work with courage to achieve success in all my missions and to make my India a developed nation. That is what we need. We need to make what his dream is, India to be one of the developed nations, and we should make his dream. That is the way we have to pay his tributes to this great soul. So before these are some of the slides that I am going to show. So initially I thought I planned for about 1 hour lecture, but now I know that it is 30 minutes. So mostly these 1, 2, 3 introduction of the space science, speed of the satellites and the space temperatures. These are fundamental basic knowledge that you need. Then I will also talk about International Space Station and the small satellite constellations. These are about 4 slides. And ISRO's 104 satellites that has been kept into the orbit on 15th February 2018, and how these are useful for the development of the world. That also we will talk about. Chandrayaan 2 also is one of our most promising, most interesting thing that we have done. Parker satellite, this is an American satellite orbiting the sun at the highest speeds. That also I will do. And this academic tree of Nobel laureates. For the last almost 9 years, I retired in 2012. Since then, I have been in academic circles. So again, my academic connections are also coming to my mind. So I will talk about the Nobel laureates whom I have some association through my professors, through some other contacts. That also I will talk about. But now 15 slides may take about 30 minutes, in my opinion. Then there are something that I want to talk about our rocketry and all, Dr. Kalam Sir's missile complex, if possible, or if it is not possible, this we will be not be able to cover probably. So let me go ahead with the first technical slide. This is the first technical slide that I am showing. This is International Space Station. This International Space Station, from one end to the other end, it is about 1,000 meters. That is the living space. And these are solar panels, 500 meters this side, 500 meters this side. It is also 1 kilometer. So this is the one which is revolving around the globe, our Earth, at a height of 400 kilometers, at a speed of 28,000 kilometers per hour. And we are able to observe and take photographs through one of the things called windows called cupola. So this one refers to the moon where when I was doing my degree, undergraduation, that time he was the 1969, or I just completed inter that time. So, Neil Armstrong was there on the moon, 1969 July, and Buzz Aldrin. Buzz Aldrin is still alive. He is a great inspiration, great motivator for the whole people who are exploring the moon, who want to go to the moon, and in the near future, say 2024 or 25, like that. So we will talk about these things. The space unites the world. The world, it was a World Space Week event title. And I talked to some of the people who are in the space, astronauts, cosmonauts, Russian cosmonauts. So I will explain to you in the one of the slides. See, basics we have to understand first. When we want to talk about space, we have to first of all understand some of the basics. This slide will tell you about the basics. Here you can see on the y-axis altitude from the Earth's surface, and this pale yellow color, pale blue color is our atmosphere. So around 100, 110, the atmosphere will end up, and then we are going up to 400 kilometers, which is called here, it is the International Space Station. Just I have shown you about 1,000 meters or 1 kilometer length from one end to the other end, the living place, where one of our familiar names is Sunita Williams, Indian origin woman. She was there in this space station 2 times. One term means about 6 months. So one term means about 6 months. So she was there in this International Space Station. Now it is revolving around the globe at 90 minutes one orbit. 90 minutes, only 90 minutes. So then this is about the Hubble Space Telescope. This Hubble Space Telescope is at about 700 kilometers altitude. You know, our missile, Agni missile, go up to 700 kilometers altitude. Then travel in the space for about for 5,000 kilometers or 6,000 kilometers, that is designated distance, then re-enter into this atmosphere. See, when it is re-entering into the atmosphere, here is the real problem. What we call plasma will be generated. Because these air molecules here they are very low density also, but they hit like bullets, and in milliseconds time, 100 millisecond time, the temperatures will raise up to 3,000 degrees centigrade. Anything will be burn off. That is the thing problem. So you may remember Kalpana Chawla's tragedy, Columbia tragedy we call. Kalpana Chawla, one of the worst things in the history of space science. So Kalpana Chawla, she was there in the space for about 16 days while returning back on February 1st, 2003. So she, the whole group of 7 astronauts, they that Columbia tragedy has happened, and we always pray on that day our remembrances to Kalpana Chawla and all. Now let us look at this. Here, what is the speed of ISS? This is in kilometers per second. 7 to 7.5 kilometers per second is the speed of International Space Station in this region. You see this equation, simple equation, V is equal to square root of Gm by R. What is G? Gravitational constant, and M is the mass of Earth. Mass of Earth. So velocity of any object, irrespective of its weight, there is no weight of the satellite. It is the mass of the Earth, not the satellite. So it is actually a dependent only on the R. What is R? R is the distance of the satellite, height of the satellite, or you call it altitude of the satellite from surface of the Earth to its position. So now this is R is about 400 kilometers. Here you can see here, this is logarithmic scale. So 100, here it is about 400 kilometers. So this is 500, so it will be something like this, 400 kilometers. At that time, this is a wonder. This is a wonder. Actually, all our satellite technologies are because of this fundamental property of gravity. So now if you go further up, that is around something Lagos satellite is about 19,000 kilometers. No, it is less than that. So Lagos is a reflector satellite, laser reflector. This is used for measuring the precise measurement of the distances and all. So Lagos satellite, there are 2 Lagos satellites. This is a reference satellite. It is very, very important. These are all laser reflectors. The surface of it, you see dots. These are all laser reflectors. So this is for the reference measurements, or for a standard, you can say it is a standard measurement. So techniques, 2 satellites. Then if you, this is at about around I think the distance 5,900 kilometers is the altitude of this, but that is not adjusted by any electronics. That is kept there, and it will be sending laser lights to the surface of the Earth and measuring precise measurements. So Lagos satellites are something which one has to use it as a reference beam. Then you come up to further thing. Here you get GPS satellites, geographical positioning systems. This is also, Lagos is also in middle Earth orbit. This is also middle Earth orbit. So here it is about 20,000 kilometers altitude. At 20,000 kilometers altitude, GPS satellites, American GPS, or it may be Galileo satellites of Russia, Galileo satellites of the European Union, or the GLONASS of the Russian satellites. All these satellites will be operating here in this regime, that is about 20,000 plus minus 100. So now Indian GPS I have talked about. Indian GPS, the satellites of Indian GPS are actually not at this level. We have kept our regional satellites at a height of 36,000 kilometers, that is called geostationary orbit. Geostationary orbit, that is 36,000 kilometers. These satellites, 7 satellites only, out of this, 3 are in the equatorial plane. See, geostationary satellites, same altitude, if you are tilting it, same inclination if you are giving to the orbit, so at about 30 degrees angle inclination, 4 satellites are running. So all these 7 satellites of our, the 4 satellites which are orbiting at an inclination, those are called geosynchronous orbit satellites. So these 7 satellites of Indian GPS are at this height, 36,000 kilometers. And here, this is why it is called geostationary, because this 3 kilometers is the speed of 3 kilometers per second is the speed of these satellites. And Earth is on the surface of the Earth. If you put a receiver antenna radar, so then all these things will be able to focus with the same thing as though stationary. What I mean to say is, it is Earth is here, here is our satellite beam coming, and if this is moving, this is also moving like that. So that is why it is called geostationary. With respect to the thing, receiver on the Earth, it is stationary. So now these are about 36,000 kilometers height. Now if you go to the further up, here is about 1 lakh kilometers, then 4 lakh kilometers, 3,85,000 kilometers. The moon is there. So the moon speed is about 1 kilometer per second, only 1 kilometer per second. See, right now, people are thinking, planning to go to the moon, and NASA is making a lot of plans to have a gateway, that is gateway to the moon, or it is like a space station of the moon that will go around the moon. So that is the work. Artemis is the program they are having. So these things are going to happen within a few years time. Now I want to tell something about recent things, that is this Blue Origin. They have gone recently into the space. They have gone up to 110 kilometers height here. See, the difference between a person coming from International Space Station 400 kilometers height to the Earth landing. See, this is very, it will face here a lot of what called re-entry problems, because the speed is very high, 28,000 kilometers, and Earth's gravity and all, it will be there. But astronauts which are returning in the Soyuz capsule or the SpaceX the recent SpaceX capsule, they face high G. That is, if I am 60 kilograms weight, in addition to my static weight, 60 kilograms, there will be a kinetic weight which will be 3 times that. So that is 180. Total 240 kilograms I will feel for about 6-7 minutes when we are traveling from 100 kilometers up to 35 kilometers. This is really a very big challenge. The astronauts are trained mainly for surviving in this type of high G effects. Whereas our people who have gone Blue Origin, it has gone up to 110. So Blue Origin people, they don't face that, because that is not having that high G effects. It is at a very low speed. So compared to this, and then they will be able to, they don't face that only zero gravity they will face, but not the high G effects they don't face. So physically, even if you don't train, only any ordinary citizen who is interested, who can spend, he is able to go into that space. See, one more thing, Bandla Sirisha, there is one more thing, Virgin Galactic. They have gone only up to 86 kilometers height, but that also is space, because there also you will face because almost the microgravity conditions. So they are able to fly 3 minutes around that time. So here, if we want to talk about how the astronauts are coming, how this actually re-entry is happening, a lot of technologies are there which takes one full session actually. The International Space Station returnees, they are giving lectures or training lectures to the people who are going to become future astronauts. So some of the lectures will be available, and one can read those things or see the video separately. Now I will go to the next slide. These are the temperature aspects. See, space temperatures, the space suits people are using when you go out for EVA, extra vehicular activity, extra vehicular EVA, because to repair or to put recently the space solar panels on the International Space Station, they have gone out. So when the astronauts are working outside the International Space Station, then their spacesuit will experience one side light, another side shadow. The one side light portion, it will be plus 250 degrees. On the other side, it will be minus 150 degrees centigrade. And all this will be in the spacesuit. The coolants will be running with the motors, and that is balancing in such a way that our body temperature will always be remaining comfortable. So if you see the principle, the temperature, what is observed, what is measured in the universe is minus, that is 2.7 degrees Kelvin. 0 degree Kelvin is the absolute zero. 2.7 K is the lowest temperature that is measured. Absolute highest temperature, theoretical temperature is 10 to the power of 32 Kelvin. Whereas highest known temperature or measured temperature or something like that, so it is the background, microwave background temperature, radiation temperature, that is 1 into 10 to the power of 27 only. So there is an order of difference of 5, which is not being observed. So these are, here we are hovering up to 400 kilometers somewhere here, and here is the temperatures. We can see these colors will indicate what are the temperatures and all. One can see these things here. We have given up to 10,000 kilometers, but it will go further up. 36,000 kilometers to the moon, 4 lakh kilometers we have to write. But it will be more or less in the space above this 600 kilometers, it will be asymptotic. Now, I want to talk to you about the International Space Station. There are people aspiring, I want to be an astronaut. So you can see Bandla Sirisha, who has recently gone in the Virgin Galactic. She wanted to become astronaut, and very nice, very nice. She has been successful in going in the up to 86, above 80 kilometers height, like that. So here is our International Space Station. The what we call solar panels are removed, and we are only showing this one end progress. This is a Russian compartment. This is service module. This is also Russian. The initial things are this. And then FGB, where they store most of the material cargo. They are sending cargo satellites, and the material is stored here. Their food, all clothing, all that will be here. And you can see here node 1, that is called Unity. The node 2 Harmony, node 2 is Harmony is the end of it. So that is American part built thing. And then Tranquility, I think it is European thing. Node 3, node 3 is this. And node 3 is used mostly for these exercise activities by the astronauts. There will be 6 people usually living in the thing, but now, right now, I think there are 7 people in the astronauts or cosmonauts total in this international space station, in the international space station. So you can see here some of the things. This is the sleeping compartment. This is I think toilet. This exercise. This is where they can sit together, and it's like a meeting room, meeting hall, and this is a position where you will be, your things will get docking compartment. And here you can see this is destiny bottom. You will find this cupola. Cupola is the thing which is facing downwards to see the earth. So most of the time, when they were taking photographs, they are taking from through these windows. And here is the JAM Japanese module, Japanese lab. So you can have an understanding of the station even without going into the full details. You can have technical data in the literature in the NASA website, but not immediately gone. But you have to go and search for it. Okay, next. This is how they live. Sunita Williams, you can see here the photograph. She is doing some, I think, maintenance work for this. He is a barber type thing. They are doing their own hair cutting. 6 months they stay. So all the normal things they do themselves. So here, yeah, this is a meeting hall. I told once in a while, very rarely they meet. So say they on a happy New Year day, they will be having 16 times. They will go around 90 minutes one round. So suppose each one is from different country. He will celebrate my country's time, like that. So like that, they will be meeting. And here is the one. Actually, you see, this is facing towards the earth because they are not having this a massless or weightless environment. For an astronaut living in the ISS, they don't feel which is up, which is down. But this cupola, they will make it in such a way that it will be facing the earth. That earth facing cupola side is bottom, and the remaining is up. Here you will find this circle. This is the just now I have already told when they come docking. See, earlier this is the way they were docking. About 4 years back, when I was observing this is the Canada arm, the robotic arm through to which is catching this incoming astronauts, carrying astronauts or incoming cargo or anything. So then it will be docking through the by the use of computer inside the International Space Station. You seeing through the cupola under. But nowadays, the SpaceX has come out with autonomous docking, laser-based docking. So it is interesting. That is the technology is really super. It has eased the troubles of the astronauts inside to a great extent, and it is very precise and absolutely problem-free. Here is a person whom I am referring to. cosmonaut. He is Russian cosmonaut. Center person in the photo is Russian cosmonaut. His name is Shalijan Sharipov. He was there in Expedition 10, 6 months on the International Space Station. So during his 190 days mission on ISS International Space Station, he has observed around Earth around 3,000 times. He revolved around there 3,000 times. When I met him at the conference at RCA, 2019 February, he actually because he has been expressing how he was feeling there and all that. Then one message he has told, as we see from the space, no boundaries found between the countries. And he says all the human beings should be united without any boundaries among ourselves. That means no, we are all one. We are all on this planet Earth. Only one planet, one Earth. So we are all one, united. Space unites the world. The first thing what I have put in the slide, space unites the world. So that was the most important thing for all the human beings. In fact, all the border disputes, everything can be solved technologically, I believe, because everyday imagery is possible using these small satellites. I will talk about that in the other slide. So that will, so all nations, if they see their boundaries which are being observed or photographed every day, then they will see, oh, what I am doing is people are laughing at it. All the world is laughing at us. So let us not go to that extreme, and we mutually resolve our disputes. Like that, one can go about it. So next slide. These are the small satellites. These are the small satellites. 104 Dove satellites launched by the SHAR on February 15th, 2018. Dove satellites belongs to which company? Planet Lab. Who is the CEO of Planet Labs? Sankaran Sivaprakashan. So the Planet Labs itself belongs to Google. Google CEO is again Sundar Pichai. So directly or indirectly, these everyday observations is being done. Everyday imagery is done by more or less the people behind it are Indians. I am very proud of it. Okay, now let us see. The companies are American companies, world companies. Here you see the pink or yellow colored things at 11 o'clock. This is actually one set of satellites, not many. These are all one set of satellites. Here it is yellow color, which is at 11 o'clock. At 10 o'clock, sorry. Now 10 o'clock, this is this position. Now green color will come. That means the whole thing yellow has position is now it is in green position, like that. So you will be able to see the same constellation will be orbit will be tilted from one end to the other end and go on taking the images. Okay. Here. And what the small satellites, what the another thing is there important thing is high speed internet access across the globe. You know, SpaceX, they have put Starlink satellites and it will deliver high speed broadband internet to locations where access has been unreliable or expensive or completely unavailable. So SpaceX is doing the Starlink thing, and the Google's Planet, SkySat and Dove satellites constellation will give high resolution imagery daily. So this will solve a lot of boundary problems, I believe, if they put it into use. So United Nations may opt for these type of images to settle the disputes in the among the nations, among the participating nations, we can say. Please remind me how much 5 minutes before. Okay. This is our ISRO's one of the achievements. See, this lunar orbiter, I mean Chandrayaan-2 mission, when we have started on that mission, it was going around this. So this is called EPO, injection into the Earth parking orbit. You remember, you try to understand this. Here the distance is 170 kilometers, which is very nearer, less than even 200 kilometers. At this height, the speed is tremendous. But if the distance increases on this other side, it is increasing, it is 40,400 kilometers. This one is the distance between this point to this point is 40,400 kilometers. So it is what we call a Molniya type orbit. Molniya type orbit. See, for communication satellites, Russia uses this type of Molniya type orbits. So that here it will spend, because they are tremendously fast, it will only spend 1 hour here, it will spend 10 hours here. So the signals for the Russian communication satellites, they are getting signals from their satellites for 10 hours, whereas it is in the northern hemisphere after above, far away towards the North Pole side. So this type of orbits, if you go on increasing, this we called, this is the away, the antihelion, ephelion distances will go on increasing. So you make it up to this point. When the satellite comes to this place, give a little bit propulsion, the engine should push it so that tangentially, then it will go like this. And if you give, when it reaches this, again you give a push, then it will go like this. Finally, when it reaches around 3,000 kilometers, 3 lakh kilometers and plus, then it reaches the lunar transfer object trajectory. Now it will be smoothly, instead of coming this side, it will be attracted towards this, and it will be going around the moon. That is how it. And we are about to usually lunar orbiting the gateway will be at a altitude of 100 kilometers only from the surface of the moon. So you can see here, this is the one what we have sent. This is the orbiter, the yellow one. This is the lunar lander. This will be running, say, from 2019, 7 years from 2019 up to 2026. So it is orbiting the moon, and we are getting the results. Life is 7 years. So this is working perfectly. Now what happened was, we got a little bit trouble when we are landing this portion, that is our lunar lander. It is supposed to be working for 15 days when the sunlight falls on these solar arrays. And after 15 days, these things will go into the dark, and it will never be able to recover again, because once it is cut off, solar power is cut off, even after some time, when it falls or it is falling on this, it may be totally dead. So that yet when it is around 1 kilometer from the surface of the moon, it has not been able, it has crashed onto the moon. That is what has happened. Anyhow, we have been able to get the data. Our people will always be getting the data from this, and we will be able to know about it through the website, ISRO website. So another aspect which is really about the velocities of the satellite. This Parker solar probe has been going around the sun in a Molniya type orbit. This distance is about 61.6 lakhs kilometers between the surface corona and to this one. And it is going at a speed of space 6,90,000 kilometers per hour speed. That is a very tremendous speed. And fifth close flyby at the perigee of the orbit around the sun was on June 7th, 2020. We will see that how the orbiting thing is happening. Next slide. Here is our here is the sun. This is our Mercury. This is the orbit of Venus. This is the orbit. Blue one is the orbit of Earth. Now you can see here. See, it started from here. 1 round, 2 rounds, 3 rounds, 4 rounds, 5th round. At 5th round, we are now at the 5th round. So this is about 66 lakh kilometers. So you can see here 2024, 2025, 2025 up to that they have planned it. 2018 it started, 2019, 2020, 2021, right now 2022 and 2023, 24, 2025. So up to that it is planned. You can see here. Now watch. Here you see 160 kilometers is the maximum speed kilometers per second this satellite will fly. This satellite speed of the satellite will go to, here you see 100 coming sometime. So you will be able to understand there is no satellite which has flown at that speed so far. This is the only satellite experimental thing they have planned such a height, such a speed it is flow. It is that speed will be here. Maximum speed will be at this place. See here, only short time. Third decimal is third point is not there. First 169. So that will be when it is reaching this point. Now we will be, as an academician, I have been telling. As an academician, I have been telling I am interested to talk about my academic connections with the Nobel laureate, my professor's academic connections. He is my professor, Professor Anil Biswas, and he worked with the double Nobel laureate, Professor Linus Pauling, in Palfrey Institute of Technology, his postdoctoral work. Then after working with him, I went to Trinity College, Dublin. Here in Trinity College, Dublin, you will see, I was working in Trinity College, Dublin, is Professor E.T.S. Walton. He is the Trinity College, Dublin professor in 1980 period. He died in around 1995. This is
Professor?
Rutherford. Hello, sir.
Yeah,
Hello.
I'm sorry for interrupting. We are beyond time.
Okay.
Can
1
you
minute.
wrap it up? Thank you. Sure, no problem. Thank you.
One minute. So Professor Rutherford, atom structure, nucleus, everything we know. So it is he died in 1937 due to hernia problem. He is John D. Cockcroft. Both of them got Nobel Prize, and he worked for Manhattan atom bomb projects. So I have some academic connections. I just wanted to close this. Okay, I will be. This is when I worked in Japan. Again, another gentleman who is a veteran. I wanted to tell, but anyhow, due to time pass, I am closing it now. Thank you so much. I don't know how much I am able to make you sense, but I have been very fortunate to have this conference as a keynote speaker. I am able to do my as a senior citizen what I can provide to the students. Thank you so much. Thank you all.
Our pleasure, Professor. And thank you so much for that lecture or speech. Next, it's our immense pleasure to welcome the Professor of Civil Geotechnical Engineering, University of Baghdad, President of Iraqi Geotechnic Society, Iraq. He is a BSc, MSc, PhD, MISSMGE, Professor of Civil Geotechnical Engineering, University of Baghdad. His main responsibilities are member of Civil Engineering Department Board, teaching postgraduate courses in Civil Engineering Department, teaching undergraduate courses in Civil Engineering Department, supervising final year projects, supervising MSc thesis, supervising PhD thesis. He has been a member of the Civil Engineering Board, Baghdad University. Sir, we request to deliver the keynote speech to the conference. Let us welcome Dr. Mahdi Karkush. All right, next, let's move on. I think we will move on to, it is our immense pleasure to welcome the Director, Professor at NFCT Malaysia and Pro Vice Chancellor Academic Research, GNS University, India. He is an educator, edupreneur, educational consultant, academic administrator, and professor of Nilai Field Research Center, Malaysia. Having 18 years of experience, he has worked in institutions like University Institute of International and European Studies at Netherlands, Merjaya Business School in Malaysia, International Teaching University, Georgia, East Europe, University Utara, Malaysia, in Malaysia, MOHI and Ministry of Manpower, Sultanate of Oman, Symbiosis Center for Management and HRD, India, and many more. He was the director of DBA programs, UNIS Netherlands, head of Leadership Innovation and Change Competence Center, OYAGSB, UUM Malaysia, and coordinator of research method courses for DBA and research programs in Malaysia. He was the director of corporate relations and training during his tenure with AIMS India. He was selected as the best employee in MOMP colleges and got the outstanding performer recognition in academics from MOHI Oman. Working knit with the academia, he has published 170 research papers and case studies in management, including 55 ISI and Scopus journal papers, 56 online articles, 9 books, 3 monographs, 6 papers and edited books, several case studies, including the Emerald Emerging Marketing Cases, and presented more than 70 research papers in international conferences. He has secured several funded projects for ministries and corporate. He is the editor and editorial member, also a reviewer of several international journals, including Scopus journals. He has secured Best Research Award, GLCA, Best Paper Awards in IBRIICT Conference, SJBIT Conference, and IPE National Conference in India. He has engaged a member in quality assurance and accreditation process that enhance the institutional growth. He is the external examiner of PhD and dissertations of various international universities. He worked as a corporate trainer in the areas of HR and management. Sir, we request to deliver keynote speech to the conference. Let us welcome Professor Dr. Dilip Kumar. Hi, good day, sir. You're on mute.
Thank you,
There,
Jojo.
there you go.
Thank you.
Hello, sir.
Good morning to one and all the delegates, the keynote speakers, the respected, what you would say, the guest of honors, everybody. And this is the second time I'm coming down to IFERP conference as keynote speaker. I just finished maybe last month or something, right? Thank you, Sudhagar, and thank you, Pooja, everybody. And let me start this short keynote speech for this particular conference. And I'm going to share you the, what you would say, slides. And you will be able to travel me the content which I'm going to present today. And it will be an eye-opener for you, everybody, to see the things, how exactly the movement happening in engineering and what you would say, specifically connected to the innovation field and likewise. So this is a conference theme basically all about are we visualizing towards a self-reliance or not? This is a question we need to really look into in this conference. How come we can talk about, India can talk about self-reliance, or how we can develop an ecosystem which is leading to engineering and innovation ecosystem. So I'm going to take you towards this, what you would say, the field of engineering, and then connecting to the management, and finally going to the innovation challenges. But my major focus is connected to innovation challenges, right? So let us have this understanding on engineering, the movement which is happening, the innovations which are happening, and finally it is connecting to the challenges and a solution. Look at this, 21st century engineering and innovation. So many aspects. So many aspects. The world is moving towards tech. The world is moving towards heavy innovation, equipments, intelligence, connecting to business, connecting to different sectors of industry. Look, the first one, digital to biological converters, DBCs. They can print genetic code based on the digital instructions sent from anywhere. A prototype. But as errors get worked out, the inventors hope that the hospital will print off personalized medical treatments for the patients in mass-produced vaccines to combat outbreak. New inventions coming up. Look at the train tracks now. Rails need to stay straight, but floating bridges bob and sway with water beneath. Not a good match, not a problem for sound transit new projects. People are thinking about the floating bridges. One example is connected to the Mercer Island in Washington. Another, replicating robot arms. It is quite common now, quite common, specifically in the supply chain industry, and many sectors exactly engineers are involved in it. And the cost is very less itself. So it's a core robot, which means to play the role of human being, which whatever they can do with a precision in the field of any options coming up. Coming to Hive in Scotland, 5 turbines bob in the nearly 4,400 foot, what you would say, deep waters of the coast of Scotland, generating enough power to meet the needs of around 20,000 homes, where the technology is taking towards us. And we need to understand these changes when we talk about engineering and innovation. Coming to the translucent roof that closes like a camera, like a petal, above the main seating ball in Atlanta's new stadium. Look at that. It's like a petal, it moves and it closes down. And it's like a camera capture. And all shielding fans and players from the inclement weather exactly. It's right of shield. Coming to the sea-dwelling snake watch. Repairing underwater, it was so difficult in it. So the advantage of it is, it's a great gig for a robot snake. It's like a functioning like a robot snake, and likewise underwater, easy for the engineers to operate. Look at aqua refining, a clean way to recycle lead acid batteries. So here, they are trying to They're trying to refine. They're like aquametals, new the way. They're trying to look at the things in, that the temperature connected with the smelting harmful emissions. They try to reduce that. Fuel emissions and likewise, it's going to reduce. So it produces purer, high quality lead than the traditional methods. So we are moving away from brick and mortar culture of our engineering pattern to highly innovative modes. Look at Bread Bug Army to fight Zika or chikungunya. This debug seeks to stop them by releasing a small army of bacteria infected. That means Aegypti. That's the kind of bacteria it is affecting, and it's releasing this kind of debug and it is really resulting eggs won't hatch. This is the advantage of it. They're not going to put the eggs, and it's not going to release as new larvas. And releasing 20 million out of the little guys near the French Coast. It's going to be across the globe in short period. 3D printing, don't want to talk about it. Hundreds and thousands of engineers talking about this one. So easy for us, at the same time, 100 times faster. Coming to synthetic spider silk for consumers. It's very strong, light, and acne-inspired threads exactly. It's almost like silk, and it is glowing like anything. So that could be a renewable alternative to the petroleum-derived fabrics. Look into huge cost around the thin rail. Rocky Mountain constructions, the construction field, and likewise, single-seat cars, open air on air side, and they whip around turns and loops and speeds up to 50 miles per hour. Now see the revolution going to happen. A lot of solutions engineers are providing, and a lot of innovations parallelly moving on. But a lot of challenges 21st century is facing, connected to the engineering field, connected to different fields exactly. I'm not talking about grand challenges. Many challenges 21st century is facing, not only engineering. Look at the knowledge economy, 20th century to 21st century. Moving from the products to the ideas, manufacturing to the service, public policy to the markets, monopoly to innovations exactly. 100%. Take an example of the COVID scenario. This monopoly of the drug pharmaceutical companies have finished. And they're trying to get this, and a lot of it, take an example recently, Taiwan has developed their own COVID-19 vaccine. So China cannot dominate, India cannot dominate. So people started looking upon indigenous innovations. This is a change you can see. Look at the globalization. Global economy, it's not local economy now. You have to do the business through cross-border, multinational, cosmopolitan countries, and likewise, minimum, you have to look at the options of doing business across the nations. And the divide between the rich and the poor is increasing day by day. And the global resources like oil, water, specifically taken into consideration of India, the petrol cost is going up like anything. We don't have that resource. Hence, because we have to import, and hence because we won't be able to catch up with our economy, impacting our society. And it is also causing that means gas emissions, all kinds of issues connected to the environment. So the sustainability issues are creeping into the picture. Look into the demographic changes, which is happening, most challenges, aging societies. And our aging population is going up like anything. So in order to occupy second line, the youth has to be prepared. Issue is that neither the youth could able to catch up with the technology changes, nor the aged population. We are exactly moving to this metaphysics stage. Now look at the global teenagers. Rate is increasing, and they're going to occupy the places occupied by hundreds and thousands of experienced people. And there is high population mobility. You can travel from one country to another. Economic airlines available, options of settling down available, options for resident pass and employment, everything turned to be so easy for the teenagers as well as the professional community to move on. And a lot of cultural diversity. You have to work with teams. One engineer coming from Japan, one from Philippines, one from Asia, one from America, one from Africa. You have to know this cultural diversity. And it also creating issues connected with the decision making because of the cultural stereotypes. Look at the technological change. Exponential technologies are coming up. I have shown you a few of them. I shown you connected with rail and roads, connected with construction, connected with the chemical, connected with the bio. So absolute disruption of technologies, robotic applications, augmented realities, virtual realities, artificial intelligence, neuro-linguistic programmings, connecting that to deep learnings. It's a world of data science. Technology changes also. And it has created a lot of changes in the psyche of human being. And they're also changing continuously. And they're more tech-oriented, not relationship-oriented, more tech-oriented exactly. And it is affecting the social institutions also. People are not talking each other, but they're talking continuously on the mobile phones, or they're going to the games and like there's all kinds of gamifications where they are engaged into. Look at the changes happening in society. Technological innovation specifically taken into consideration of commodities to innovation, analysis to synthesis, reductionism to consilience, and hierarchy of networks. Complete technological innovation is happening across the world. And there exactly we are organizing this conference to understand and discuss and deliberate the innovations in the field of engineering, technology, and research. So basically I'm taking, let me take you to the crisis which we are exactly for. And we are into this pandemic, lasted around 1.5 years. Start from 2020, September 2019, I think so, that days onwards, we are exactly into this process, engaged into that. Lack of vaccine, a lot of issues connected. 2019, September onwards, we are into this. And it's going towards the second year. So look at that. So a lot of changes. So this pandemic has appended, that has penetrated every aspect of like professional or personal, customer relationship, stakeholder relationship, financial return of investments, looking at the designs of the products, looking at the branding options. Everywhere you can see this change. Even the sentiments of the customers have changed, whether it is industrial product or it is data related product or any kind of products which are available in the world, the sentiments of the consumers changed just because of the COVID-19. So McKinsey has conducted a research on 200 organizations across industries. And I would like to share that report to you. As one of the leading consultants in the world. And it is clearly indicating that this COVID-19 has heavy impact on customer needs, means that the changing pattern of human experiences and their preferences towards different kinds of products. And it's going to last the next couple of years. So our new generation engineers have to focus on what kind of requirements the new generation customers need, and don't look at what exactly was doing in 2019 and backward. You need to have new normal aspects, new normal customers. Post-COVID scenario, we have to think about it. Look, the response from the executives. 90% of these 200 executives surveyed, they believe that COVID-19 crisis will fundamentally change the way they do business over the next 5 years. 85% of these executives are concerned with, and they are telling about this COVID-19 has its impact, a lasting impact on customers' needs and wants over the next 5 years. And 21% of these executives, they believe that They have the expertise and the resources and commitment to pursue new growth successfully. But what about the next? That means around 79% of the people. So this 21% only has the confidence, the rest don't have, and they're stuck up. And they have stuck up. So another is 2/3 of this believe that this will be most challenging moment in their executive career. Whether you are an engineering executive or it is a normal executive, it doesn't matter. It's going to impact your professional life. Look, is it an opportunity for us? Let us ask this question. Is it an opportunity? Certain sectors quite okay, but the rest, I'm not sure about it. Look at the industrial, basic materials, communication initiatives, and likewise. But prominent sectors in this particular type of COVID, where the products to be generated through the engineers include the consumer packaged goods and technology related products. Of course, pharma is also performing well. Financial services cannot agree completely with that. Still, I can tell you yes. So certain sectors specifically likes pharma and likewise technology, it has increased. It is supporting. Didn't have much impact, but rest of the sectors, specifically taken into consideration of travel and tourism sectors, hotel industry, all are badly affected. And here what we are observing is that the commitment to innovation has completely gone down. Engineers are in the struggle to understand what exactly required for the society, that industrial sectors have to identify, then pass it to the engineers, and they have to look at the innovation options. How to attract the customers, how to look at the new needs of society. They're not sure about it. So look at the data given by McKinsey. You can see a drastic fall here from 55% to 23%. So look at everywhere, innovation gone down, mergers and acquisition gone down. And you look into here, organization health, it is increasing. Why? Because safety related, health related products, pharma related products, drugs, their engineers, chemical engineers, all these people have this option. Rest less, car purchasing gone down, vehicle purchasing gone down, capacity gone down. So where exactly the engineers have to focus now? We need to decide on that. Efficiency also, a little bit increased on certain sectors, not everywhere. But you can see a little bit increase finally on the core sectors also. But it is not the level of growth which we were seeing in 2018 and 19. A radical change is going to happen. And our new generation engineers, the scholars, the faculty members, the colleges, engineering colleges have to look into this crux, this issue. So innovation reduced to few sectors. This I want to tell. This is a message I'm giving through this conference, but it should not be like that. Our engineering college ecosystem should facilitate this innovation aspects more, connecting to entrepreneurship also. There is a possibility, high-tech possibility. So as it is mentioned, some sectors, rest of the sectors are totally affected. And you can see that the materials and the communication, all these sectors, the variations, pre-crisis normal and the normal level. You see that the industrial sector here, it has drastically gone down. Retail sector drastically gone down. And here, you see here, basic materials all have a low level of innovation as well as the probability for the production, it's very less. So this report is giving you an eye-opener where exactly our world is moving in the challenging period. So the future of innovation, if you look upon that, it's there, but it's moving. This is exactly a history talking about innovations, and likewise through every crisis we have faced, whether it is AIDS affected period or it is connected to the MERS or any kind of pandemic affected, it will recover. but it takes a little more time, So 5 years gap, sure. And these days, the engineering students, the people who are pursuing their career as engineering, they have to be very selective on specializations, which is long lasting, should be taken into consideration. So the things we have to look at here in this knowledge economy is new knowledge research, more human capital connected to the new normal, infrastructure facilities, and we need to really look into the policies, industrial policies and engineering related institutional policies and likewise. And it will be leading to technological innovations. So national priorities connected to, global challenges connected to, and opportunities we have to really look into. And that kind of ecosystem should be provided by the engineering colleges and the ecosystem or the university ecosystem. So when you look upon this, you can see here a lot changes. All right. So the grand challenge connected with this knowledge economy, global sustainability, infrastructural issues, energy issues, public health, poverty, a lot of issues. So here, education, government, business, NGO, policymakers, everybody has to look into, because these are the areas where new options are coming and new policies to be generated. So the skills, engineering and technology is going in. It's going to lead the world exactly. It's not the social sciences and other kinds of subjects going to impact. Science and technology going to impact. And we call it as SEI, science and technology, and STI, science and technology and innovation. So different courses we need to look into. Engineering researchers, they have to look into a kind of ecosystem. And the tools also, cyber infrastructure, collaborations, all these things turn to be a big challenge for the university ecosystem. So the message is going to be like that. The role of science and technology innovation is increasing day by day. You need to understand the difference between science and technology. We call always together, but it has its own different meaning. Scientific activity and technological activity. Scientific activity basically augmenting the knowledge alone. But technological activities are exactly facilitating that augmented knowledge through human operations. So even though we are using the term science and technology heavily, we need to understand where exactly the augmentation happening, where exactly the application happening. So it is evident then that engineers make significant contribution to society, leading to heavy innovations across the fields now. Biotech, biosciences, pharma industry, everywhere their role is proven now. In US, technological applications of scientific discoveries account nearly half the nation's economic growth. So you look how the engineers can contribute to our economic growth. Hence, the education and training of engineers to contribute to innovative innovations or endeavors is critical, extremely critical to economic strategy. Government, Indian government or any kind of government existing has to look into this option. Any countries have to promote the engineers and they should promote innovation. So look at this major engineering challenges of next decade. Specifically, I'm taking into consideration of the US when they are facing extreme challenges. Almost similar situation will be happening in a couple of years on us. And it has been clearly mentioned that the aging infrastructure identified by US, connected to roads, bridges, water, electrical, sewage system, everywhere you can see, it's all outdated. And aging infrastructure is one of the challenges they are going to face. Educating the first world engineers to understand how to solve third world problems. It's not exactly we are serving always the cosmopolitan needs, metropolitan needs. We have to look at third world programs, developing countries program, underdeveloping countries problems. This is engineers have to refocus now. Don't focus on big US companies and all kinds. They have to focus on the needs of society. There lies the relevance of engineers. Promoting green engineering to improve sustainability, another important aspect. We have to reduce the carbon footprint. Specifically, the manufacturing industries are involved in this process. So we have to look into this green engineering process. Identifying viable alternatives to energy sources. We have to look at alternative energy sources for survival. We cannot simply depending upon specific types of sectors. So diversification of energy sector is very important aspect. According to this BP, 6% the new fuel sources are growing and have to increase up to 45% till up to 2035. So the requirement of, so engineers, energy related sector may be a booming sector coming up to you. We have to focus on engineering specialization connected to energy sectors. Another is rethinking how the city looks like, application of artificial intelligence, smart gardening, smart beautification, smart cities, smart grid, smart water system, water distribution system, and else like open the door, they are opening in the houses. Exactly these virtual realities and augmented realities are exactly playing key role. And there exactly lies with new opportunities for the engineers. Making the STEM more appealing to young students. This is another challenge. A lot of people are enrolling into engineering, but majority don't get any job at all. What's happening with our system then? Engineering education system. You look at UCLA study, 40% of the students enrolled as STEM majors switched subjects or failed to get a degree. I'm seeing that. I have an experience of around 11 years in abroad. When I was in different campuses, different international reputed universities, I was seeing that they're all enrolling into engineering, but very less people are clearly getting into aspired or career-oriented engineering jobs. And they may switch over to different. So after the BTech, they're going to MBA. Even after MTech also, they're going to MBA. So they're trying to, they're understanding that much of future-oriented, futuristic options are not there. And I did a mistake like this, they had a feeling.
Sir,
why it happened?
5 more minutes.
It's just because of the issues connected to the ecosystem. So safeguarding our personal data is another issue, cyber attacks, the climate change issues, the engineering innovation should happen. Feeding our growing population through cutting-edge bioengineering and agriculture innovations, another challenge. Improving our health and well-being through life sciences and nanotechnology, all these things we have to look into. And here we are talking about self-reliance. Look how much IITians in India we can claim as the topmost. Look at our Air Force exactly. Not a single squadron of our Air Force, which has around 34 squadron containing indigenous jets. Look at the technologies we are using, thrust vectors, nacelles. And single private aeronautical company in our country that develops fighter aircrafts. We are purchasing from outside. Look at our army, which is, whether it is indigenous, artillery system, it's not at all. Look at the headlines in the newspaper, even the High Court asked the Ministry of Defense to respond on INSAS rifle. And a lot of issues connected with that. And our Navy system, look at that. How many we have? Surface to air missiles and likewise. And the helicopters utility, very less. And how much of our Navy is indigenous? I'm not sure about it. So RAW also, the intelligence agency, they also, which is our external intelligence, has shortfall of 30% of sanctioned cryptanalysts. Look at the options. So how many of your telecommunication systems then that also facing the jitter to import Chinese telecom products exactly? Look at electrical equipments, the challenges, heavy. And I don't want to get into this tussle software, but my inference is, I'm not saying that all these work should have to be done only by the IITians. But I would have been prouder if any IITians claimed that to have started a high-tech industry in aeronautics or a telecommunication equipment manufacturer. So here, coming to engineering challenges, major 7 engineering challenges our students are facing in developing countries. We have ordinary campus, not preferred by the recruiters. We have preference given to big institutions at the time of placements, and likewise, they're not giving to these tier 2 colleges. No proper training. And expert faculty and world-class resources are totally missing in engineering. Good placements missing. And syllabus is not updated as regularly as it should be. Severe lack of live projects happening in industry, in campuses. Lesser industry interaction. Big manufacturers are not coming to every engineering college. Lesser exposure to reality, live projects I have already mentioned. Faculty shortage is very high. They can prepare towards innovation. Lack in absorbing capacity, even though innovation is happening, the faculty as well as the ecosystem are not prepared enough to absorb it. They don't have the resources and capabilities. So competitive advantage is going down. High fees and expenses because of that the semi-urban or rural people cannot get into the courses. Language is another barrier. Now NEP policy stresses that you can even teach engineering through languages. Maybe it means that through the medium of vernacular language that may be changing. So here, role of science and technology we need to understand. I'm taking around 5 more minutes with permission. So the role of engineering is know-how. And role of science is know why. You have to ask the question why, don't ask the question what. And technology is application field, you need to sell it out. So we need to have a system, a society that consumes the demand. So our engineering students have to orient towards that. Create such kind of knowledge which is required for the new normal. Ensure that kind of innovations which can meet the needs of the new normal. And produces a product with the support of technology which is readily available to the customers. So we need to have education, the curricula, material, all these things to be redesigned and reshaped. So the relevance of education in science and technology is coming up. Right? So last but not least, we have a mission, and that mission should synergize with many aspects, which include the creation of an ecosystem. Here, you can see that the political influences are the public relations, are the customer relations, are the expertise systems. These are all at the same time on the other side, suppliers. This is a kind of ecosystem we are exactly looking upon. We need to have vertical integration as well as horizontal integration. And the roadmap to the future of engineering practices connecting to the knowledge, you're connecting to the engineering, connecting to the technology, connecting to a lot of areas like bio and nanosciences, microsciences, applied sciences, and likewise there we have to focus on. So the most important aspect for generating an ecosystem is connecting education with the capability and the resources and the technological updation with the support of industrial connect. And that's all for you today. I've taken a little more time for this speech, and thanks to one and all. Best wishes to all delegates. Bye-bye.
Thank you so much, Professor. It is our pleasure. Thank you so much for that speech. And now, it is my immense pleasure to welcome back our speaker to deliver for a speech. Let us welcome Professor of Civil Geotechnical Engineering, University of Baghdad, President of Iraqi Geotechnic Society, Iraq. He is a member of Civil Engineering Department Board, teaching postgraduate courses in Civil Engineering Department, teaching undergraduate courses in Civil Engineering Department, and supervising final year projects, supervising MSc thesis, supervising PhD thesis. And he has been a member of the Civil Engineering Board, Baghdad University. Sir, we request to deliver a keynote speech to the conference. Let's welcome Dr. Madi Karkush. Hello, sir.
Hello.
Hi.
Hi. Hi. Good. And you?
I'm good, sir. I'm good. I can now see your screen. You may proceed.
Okay. Do you have see my screen on?
Yes, sir. Yes,
okay.
Professor.
Okay. 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 Thank you very much. I would like to thank all delegates attend this session, and also I thank the conference organizer to give me this opportunity to give a keynote to speak for the attendees. Actually, my lecture is specified in geotechnical engineering, civil engineering. So I will talk about the evaluation of geotechnical properties of cohesive soil contaminated with heavy metals before and after remediation. Outline of research, soil contamination, definition of soil contamination, heavy metals, which are the contaminants of soil, remediation techniques used to remove contaminant from soil, electrokinetic technique, that the technique used in the remediation of contaminated soil, testing procedure, results and discussion, conclusions, control of contamination, published paper, and references. First, soil contamination. Anyone can define the soil contamination that the build-up of persistent toxins, compounds, chemicals, salts, radioactive materials in soil, which these material can be changes the chemical, physical, mechanical properties of soil and have maybe have diverse effects, maybe negative or maybe positive. So these contaminants also can be affected the human health, the animal health, and specifically the geotechnical properties of soil, which is the branch of our research. Soil contamination is also can be defined any factor which deteriorates the quality, texture, and mineral contents of the soil. Generally, there are two types of contamination. Natural contamination, these contaminants are naturally occurring as a result of many reasons, such as the use of pesticides, fertilizers, metal mining, and industrial waste and animal dung. Artificial contamination, which is a combination of artificially occurring in order to get a good homogeneity in terms of mineral concentration, type of contamination, the process of contamination, and the period of contamination, and soil composition. This type of contamination reduces the uncertainty in the results due to the heterogeneity of the soil, which are mostly highly non-homogeneous media, not like other structural materials or such as concrete or steel. There are many different ways for soil contamination. Maybe the contaminants coming from sewage from landfill, discharge and percolation of waste to the soil, and rupture of underground pipes, structures, tanks, excess application of pesticide on fertilizers in the farms. These are the main sources of contamination which are affected the soil properties and maybe affected the other components of environment, air, water, soil, but we are looking for the contaminant affecting the geotechnical properties of soil in this research only. Heavy metals, which are used as contaminants for the soil in this research, can be defined as metals with relatively high densities, atomic weight, or atomic numbers. In metrology, heavy metals can be defined on the basis of density. In physics, can be defined on the basis of atomic number. In chemistry, can be defined on the basis of chemical behavior. Heavy metals, maybe give some examples about this type of heavy metals. which have a heavy density, such as copper, iron, lead, nickel, zinc, and tin, and others. Sources of heavy metals in soil may be coming from fertilizers, pesticides used in farms, also biosols and manures, water, wastewater, and mining in industries. So we can see in this chart the sources of heavy metals pollution, which may be attack the soil, the water, the air, as I said before, but mainly we will focus on the contamination of soil. Heavy metals enter in many industries that we are used in our daily life, such as television, pens, custom jewelry, electronics, lipstick, batteries, and ceramics, and others. The two photos on the right of the screen shows the industrial contaminants released to the soil, which these contaminants may changes the properties of the soil. So before we can use such soil as a construction material or for construction of projects on it, we need to remediate the contaminated soil, especially if the available soil is very limited or the source of soil is very limited. Effects of heavy metals on the geotechnical properties of soil. We must know something about the effects of contamination of the properties of the soil before we starting the study. Also, we must know some properties of the contaminants before we are starting the study. Then the effect of two components, contaminant on soil, will be produce another material. A very few studies have been conducted to study the effect of heavy metals on the soil sample. Also, mainly, most of previous studies available on studying the contamination of heavy metals on the geotechnical properties of soil indicated reducing the shear strength parameters, cohesion, and internal friction, also increasing the compressibility of soil, increasing the maximum dry density. This is the first two properties, reducing the shear strength and increasing the compressibility. These are two negative effects for contaminants on the soil properties, which these two components specify the bearing capacity of the soil. So when decreasing the bearing capacity of soil, we need to increase the size of foundation or change the type of foundation to support the structure. Increasing the maximum dry density and decrease the optimum moisture content is one of the benefits of contamination of soil with heavy metals, which reduces the quantity of water used in preparing the compacted soil layers, also increasing the dry density of the soil. Also decrease the permeability of soil, which meaning reduce the drainage quantity of sewage from the soil due to reducing the coefficient of permeability. Also, table 1 shows the maximum and minimum concentration of some heavy metals in Iraq according to the UNEP report in 2005, which shows the concentration of copper, lead, chromium, nickel, maximum and minimum for some location studies after 2003 in Iraq. These values, we interested from the given values in this table in selecting the values of concentration of contaminants mixed with the soil to prepare the contaminated soil samples. Remediation techniques. There are many remediation techniques can be used to remove the contaminant from the soil. We need this. We need these techniques when we have a contaminated site. The contaminated site, it should be soil and contaminated with specific contaminants. So the principle of sustainability, one of the principle of sustainability is how can I use, or one of the themes of sustainability, how can use the contaminated sites in construction. In construction, maybe we can excavate the soil to be used as a fill material in another project, or maybe we can construct a foundation of structure or building on this type of soil. So there are many techniques can be used for remediation of contaminated soil samples. The selection of the most effective method depends on type of contaminant, also concentration of contaminant, type of soil, groundwater table, also time duration, cost, and maybe other factors affecting the selection of the technique of contamination. Contaminated of soil may be classified into containment of contaminants as shown in the photo to the right of screen, surface capping, encapsulation, landfilling, or maybe extraction of contaminant from the soil, such as soil washing, soil flushing, electrokinetic, and phytoremediation, which is one of the new techniques and can be classified as a green technology. We can remediate the contaminated soil sample by planting and grazing, which feeding on the contaminants in the soil sample, and so during a period of time can be removed. But it is limited use because need long time, and maybe the remediation will be continue for a short depth, not for a deep deep contaminated soil sample. Also, we can use solidification or stabilization of soil, such as solidification, vitrification, and chemical stabilization. Remediation technique for heavy metals contaminated for soil samples can be these types of techniques under development, and we can mix some of these techniques for remediation of contaminated soil samples, especially when the soil contaminated with more than one type of contaminants. The US EPA has recorded the insufficient performance of different trace technologies implemented to numerous contaminated sites. Poor working may be due to the following technical difficulties. Clay soils, the soil used in this study is a clay soil. This soil can be classified as hard to treat because this soil have low permeability and complex structure. This means mineralogy and organic contact will be very complex to be treated, especially when we know that the particles of soil are charged with negative positive on the surface and positive charge on the edges of the particles, which is classified as the plate-shaped particles. Also, several common technologies fell under heterogeneity of the soil below the ground condition. Very few technologies are present to remediate soil contaminated with heavy metals. Also, very few technologies exist that can remediate locates contaminated by combined contaminants, as I said before, that we push us to use more than one technique in remediation the contaminated soil sample when there are 2 or 3 or 4 types of contaminants in the soil. The remediation techniques can be divided in general into ex situ and in situ. In situ, such as physical, surface capping, encapsulation, electrical, such as electrokinetic vitrification, chemical, such as soil flushing, immobilization, biological, such as phytoremediation and bioremediation, and ex situ, that means we can use physical landfilling and chemical soil washing, solidification, and thermal, such as vertification. The ex situ remediation of contaminated soil is very expensive. That we should excavate the soil and transport for a plant.
Bye.
Then we will should remediate
Hey, bye.
the soil sample. Then we can return back the remediated soil sample to the original sites to be used as a construction material or to be compacted for preparing bedding soil to construct a project or a building. Electrokinetic technique, the application of any electrokinetic technique has potential caused by the water movement through the soil, through the pores inside or between the particles of the soil. This phenomena is called electrokinetic. At first, the phenomena was first described by Russian in 1808. At first, the exclusion of electrokinetic was created by Casagrande in 1939 for stabilization and solidification of soil. The basic mobilizing mechanism in electrokinetic technique are electroosmosis, which is the moving of water under electrical current, also electromigration, which is migration of charged particles toward the negative electrode or to the positive electrode. Also, electrophoresis consists of the movement of charged particles and colloids under the influence of an electrical field. Important components. The photo shows the technique of electrokinetic used in remediation of a bloom of contaminated soil, which consists of anode, positive charge electrode, and cathode, negative charge electrode. And these two electrodes connected with power supply, and we can use pumps inside the wells to extract the contaminated migrated toward the anode well or to the cathode well to remove it from the soil sample. What are we should study about the electrokinetic dimension of electrodes? What are about the dimension of electrodes? B times L times D. Also, spacing between electrodes, type of electrodes, electrical potential, electrical difference, or electrical current, or electrical gradient between two, which depends on the type of the contaminant and concentration of contaminant and type of soil. Because using high electrical gradient may causes heating of the soil and maybe causes evaporation of water, which make the electrokinetic technique will fail because it mainly depends on the moving of water from anode to cathode and transport the contaminants from positive electrode to the negative well. Also, remediation period. This technique will stop when the electrical current become constant or electroosmotic flow will stop. Testing procedure. Disturbed and undisturbed soil sample were taken from the Al-Adab oil field in the south of Iraq. Disturbed soil sample are contaminated artificially in the laboratory with several percentage of lead nitrate and copper sulfate. A trial bit was excavated by using mechanical excavator to get a soil sample from a depth of 3 meters below the existing ground level. The designation of soil sample tested in the present study are S0, S0, R, S1, S2, S3, S4, S5, S6, and the last column of table shows the concentration of contaminant used in this study, which are copper sulfate and lead nitrate. The setup of electrokinetic use in this study consists of anode compartment and anode electrode, cathode compartment, which contain cathode electrode and contaminated soil sample. Also, in this study, we are used a washing technique combined with the electrokinetic technique. Also, so we can apply a hydraulic gradient to help the moving of contaminants inside the soil from anode compartment to cathode compartment. And this technique will help the electroosmotic to be faster and maybe save the duration of the time or reduce the duration of time required for removing the contaminants from the soil sample. Also, we use a middle compartment contain activated carbon. Also can expedite the remediation process. Also can prevent the discharge of water or flowing the water from cathode to anode. In this study, we used a voltage gradient of 1.3 volt per centimeter, hydraulic gradient used 2.86, nitric acid, also some chemical compounds used as a purging solution in the cathode and anode to control the pH value of anode and cathode with allowable limits. Then sodium hydroxide of concentration 0.1 molar used as purging solution in the anode to maintain pH higher than 2 to avoid the reverse flow from cathode to anode. At the mid and cathode compartments, we are used nitrate acid, HNO3, to maintain the lower pH at mid and cathode compartments and to continue the process of long time and increase the efficiency of soil remediation. Measurement of electrokinetic experiment are variation of electric current with time, variation of electroosmotic flow with time, also variation of pH value with time at different locations in the soil and in the compartments, removal efficiency calculated according to the shown equation, which mean initial concentration of contaminant minus final concentration of contaminant in the soil divided by the initial concentration of the contaminant in the soil. Study such as a variation of electrical current with the time of duration, which continues for 240 hours for lead contaminated soil sample S1 and S3 and soil sample contaminated with copper S4 and S6. We see that the electrical current mostly steady for the soil sample contaminated with low percentage of lead nitrate, but the soil sample contaminated with high percentage of lead nitrate shows steady state for the 40 hours, then rise to a high value reached about 300 milliampere, then draw down to be constant approximately for the end of the test. But for the soil samples contaminated with copper sulfate, which is more, which can be transported by the soil sample easily due to the low density of the copper in comparison with the density of the lead. So the electrical current mostly for low and high and soil sample contaminated with low and high percentage of copper sulfate. But at the end of the test, we can see for the soil sample contaminated with high percentage of copper sulfate, increasing the electrical current to be reached to 700 to 800 milliampere. Also, from the results of the test are variation of pH value for the soil sample contaminant with the lead nitrate S1 and S3 for soil samples contaminant with copper sulfate S4 and SC. We saw the variation oscillation of the HB value over the time of remediation. These values are measured at the anode compartment, and figure 3 shows the variation of pH value inside the treated soil, not at the anode or cathode compartments, at equally spaced distance inside the soil sample. The pH value measured for soil sample S1, the red line, and for the soil sample S3 contaminated with lead nitrate. Also, the pH value mostly higher than the pH value of soil sample contaminated with copper sulfate. And the two soil sample contaminated with low and high percentage of copper sulfate give the same trend of behavior, but the soil sample contaminated with lead nitrate shows a different behavior for the two percentages of contaminants. So pH is a master variable in chemical equilibrium and the solution precipitation aqueous phase and absorption reaction in the pore fluid. Also, zeta potential of the clay and electroosmotic coefficient of hydraulic conductivity sorry, conductivity across the soil sample may be affected by the change in pH value. The pH value of the soil should be maintained low enough to keep the contaminant in the dissolved phase. We mostly try to be dissolved contaminants in the liquid to be transported from anode to cathode or from cathode to anode. Mostly the electroosmotic, the predominant technique or phenomena of electrokinetic will be the predominant factor that affected the efficiency of electrokinetic technique and removal contaminant from the soil. So when the flowing velocity capable to transport the contaminants will be more efficient in removing the contaminant from the soil, especially when the low density of the contaminant that we are treated with. Also, figure 4 shows the accumulative of electroosmotic flow in cathode reservoir versus time. At the beginning of the test, especially after 50 to 70 hours of test or for the soil sample contaminated with lead nitrate, the flowing volume or flow volume is very low and maybe zero for soil sample S1 and S3, and during the 40 hours for soil sample S4, S6 also be zero, but with advancing time of remediation, the accumulation of flow resulting from osmotic flow will be increased and reach its final value. So we see that after 23, 22 hours of 220 hours or 230 hours, the osmotic flow will be constant. So this is indication for stopping the remediation technique. Also, we check the removal efficiency. After remediation of contaminated soil sample, we take soil samples from different locations to measure the concentration of contaminant in the soil sample. So after remediation for 24 hours, for 240 hours, by using electrokinetic may be improved by flushing solution or hydraulic gradient. The removal efficiency of lead nitrate from soil sample S1 was 12.4, from soil sample S3 21%. The removal efficiency of copper sulfate from soil sample S4 was 89.4 and S6 was 99.6%. Also, the figure 6 shows the concentration of residual lead nitrate in soil sample S1 and S3, and the second part of figure 6 shows the residual concentration of copper sulfate in soil sample S4 and S6, which is mostly lower than the concentration or the residual concentration of lead nitrate in the soil sample. The maximum value of residual is about 40 part per million, but for lead nitrate, the maximum value about 11,000 part per million. Figure 7 shows the corrosion of electrodes and filter papers after the remediation process. So if the coagulation of the electrodes is very big, so we maybe need to replace the electrode during the remediation process. But if the coagulation or corrosion is very few, we can continue the process of remediation with one block of electrodes, carbon electrodes. Effect of soil washing process. To measure the effect of soil washing process, we tried this technique on one soil sample as 4 contaminated with copper sulfate. So we denoted the soil sample as 4 star to see the effect of flushing solution or hydraulic gradient on improving or enhancing the electrokinetic technique and removal of copper sulfate from soil sample. So we can see the electrical current for the soil sample treated with a combined techniques, hydraulic gradient and electrokinetic S4 star, which shows low current, electrical current than soil sample treated with electrokinetic technique only. Also, figure 9 shows the variation of pH value for the two soil sample S4 and S4
Two more
star.
minutes.
Okay. Figure 10 also shows accumulated electroosmotic at cathode, and figure 11 shows the normalization distance from anode and the residual concentration of copper sulfate. What we interesting from the adding the hydraulic gradient to the remediation of contaminated soil sample, the same removal efficiency obtained from both electrokinetic technique only and electrokinetic enhanced with hydraulic gradient, but we are saving the time of the remediation. Instead of 11 days, maybe 10, 9 or 8 days. So we are just saving the time required for remediation of contaminated soil with copper sulfate. Impact of contamination and remediation on geotechnical properties of soil. Many of chemical and physical, mechanical properties of soil are tested. Table 3 shows the result of chemical test before and after contamination for the tested soil sample. We saw some changes in the chemical component of the soil sample before and after remediation by electrokinetic. Also, table 4 shows the some physical properties of soil sample before and after remediation by electrokinetic. And table 5 also shows some of physical properties such as liquid limit, plastic limit, specific gravity, hydraulic conductivity, and compaction properties, maximum drain density, and optimum moisture content before and after remediation. Also, figure 12 shows the consolidation curve for the soil sample contaminated with lead nitrate before and after remediation, and for soil sample contaminated with copper sulfate after and before contamination. Also, the summary of these two figures are given in table 6. Figure 13 shows the void ratio of soil sample tested contaminated with copper sulfate and soil samples contaminated with lead nitrate. So from this figure, we see that contaminated soil has higher compressibility than uncontaminated soil. Also, remediation of contaminated soil sample will recover some of compressibility of soil lost due to contamination with lead nitrate or copper sulfate. Table 7 shows the results of shear strength test of soil sample before and after compaction. Contamination causes losing the shear strength of contaminated soil sample, but remediation will help in recovery some of the lost shear strength of soil sample. But still, after remediation, we can come back to the original shear strength of uncontaminated soil sample. Figure 14 shows and 15 shows the variation of stress and strain of soil sample before and after contamination at different level of confining stresses. Table 8 shows also the undrained unconsolidated triaxial test for contaminated and uncontaminated soil sample by electrokinetic technique. Conclusion: the electrokinetic method is very effective technique for remediation of flow permeability soil. Also, the volume of osmotic flow increase with increasing the concentration of copper in soil. Also, the removal efficiency of copper sulfate mostly 98 to 99%, but the removal efficiency of lead nitrate from contaminated soil sample was 12.4 to 21% respectively. Using activated carbon as a mid compartment will helpful in stopping reverse flowing of osmotic flow from cathode compartment to anode compartment. Using the mid compartment to enhance the electrokinetic is very useful in shortening the path of drainage for removal of contaminants from the soil. Also, soil washing is very useful to enhance the electrokinetic technique by reducing the time required for remediation by 30%, increasing the concentration of copper sulfate over 6,786.933 per millim. The voltage must be less than 1.3 to avoid the heating of the soil sample and evaporating of the poor water of soil. Also, lead and copper salts make the particles of
Our
soil
time is up.
the particles of the intact soil also at the bare limits of contaminated soil samples decrease as compared with those of intact soil and converted the soil sample from high plasticity to low plasticity soil. Despite the low removal efficiency of lead nitrate from the soil sample, 12.4 to 21 of the lead from the soil samples, right? But the improvement in shear recovery of shear strength and compressibility is very useful. Also, what are we need to control of soil contamination? Reducing chemical fertilizers and pesticides use, also reusing of materials, also recycling of materials. Published paper, we published 6 papers from this thesis and references of the present work are some of the. Thank you very much for listening.
Thank you so much, Professor.
You are welcome.
Thank you so much. And now, again, thank you one and all. And now we are stepping in our technical sessions. And I would like to to remind everyone that we have 3 sessions that will be going today. Technical session 3 should remain here present in the main room. I will be your moderator, Jojo, and presenters in technical session 3A should join breakout room 1. Technical session 3A should join in breakout room 1, and your moderator will be Divine. All right, and presenters in technical session 3B should join breakout room 2, and your moderator will be Gretchen. All right, again, I repeat, presenters in technical session 3 should remain here in the main room and I will be your moderator. And presenters in technical session 3A should join breakout room 1. All right, and your moderator will be Divine. Presenters in technical session 3B should join in breakout room 2 and your moderator will be Gretchen. Please look at the agenda where you belong and proceed with the breakout room. Now, in order and how to join the breakout room, your Zoom meeting, you will see there at the bottom breakout room, or you will see there more. If you cannot see the breakout room, you will see there more. Click on more, then click on breakout rooms. When you click on breakout rooms, you will see there all the breakout rooms. So scroll down to room 1 or room 2 and click on join. All right. And if you are still having problems, please drop a message on the chat box and our team will move you to the specific room. All right. Any questions? Again, if you have problems and wasn't able to go to your own room, please shoot me a message on the chat box on what room or session do you belong so that we can transfer you. All right. And now, let me check. I'm just going to check if my session chair is already here. All right. And I would like to, let's start our technical session 3. Again, this is technical session 3 on the main room. We would like to introduce our session chair for technical session 3. He is an associate professor, Department of Civil Engineering at Guru Nanak Institute of Technology, Ibrahim Patnam, RR District, Hyderabad. Let us welcome Mr. M. Subash. Hello, good day, sir.
Yeah, thank you, ma'am.
And now, we'll start with I would like to welcome all the participants for this technical session. And let's proceed with our first presenter. Let us welcome S. Keshav Kumar Amipali to present an evaluation of co-attainment tools in OB framework for engineering courses.
Thank you for this opportunity.
Hi.
Hi. I'm trying to share my screen. Could you please confirm if you're able to see?
Sure.
Just a moment. Jojo, could you please confirm?
Yes, I can see your screen and you are audible. Please proceed.
Thank you. I hope you're all also able to see what I'm able to scribble on the screen. I'm using a pen tab here. Okay, thanks so much for this opportunity. I welcome all the participants along with me over here for the session. I'm Keshav Kumar, putting myself as assistant professor in Department of Civil Engineering, Vasavi College of Engineering, Hyderabad. Here, I would like to present evaluation of CO attainment tools in OB framework for engineering courses in specific. So I've been in this teaching field for around 6.5 years, and I have certain, though my background is from geotechnical engineering, I have certain interest in behavioral science of students, and that brought me to study this particular topic further. So here is an abstract we have. So we have India has been a signatory country for this Washington Accord, which substantially provides an equivalence between the graduates from all the signatory countries. So you have certain standards to meet. So India has adopted this outcome-based education way back in 2014. Since then, you have a lot of challenges in the whole framework at all the stages putting together, right? But this paper talks about how you can address the challenge of calculating CO attainment for a greater cost, right? So that will be our broad agenda of the presentation. And, you know, in specific, we are going to compare two different methods, though we have several conventional methods of calculating course outcomes and their attainments. We will try to compare two specific methods and try to give a contrast between them. In further to that, we are going to give an insight, or we have actually proposed a new way of assessing POs. So please go through it. So this is a broad OBE framework. We all understand every institute defines its own vision, mission, and in congruence to vision, mission of the institute, departments, or the programs define their own mission, then they further define the program education objectives, further they define program outcomes and program specific outcomes. Now, in order to assess program specific outcomes or program outcomes, they are further mapped to all the courses that are part of the scheme. And under each course, you have course outcomes that are being defined. So you have specific targets or specific objectives that are deliverable and as well as measurable simultaneously. So your outcomes are to be evaluated, right? So be it program outcomes, be it or course outcomes at course level, both of them are generally assessed through direct tools and as well as indirect tools, right? And the feedback from here is going back into the framework to actually assess and as well as to revise and establish new strategies to improvise your performance there, right? So as well as you can see, the regular inputs are there. Of course, your framework should be entangled with the broader policymakers as well, right? And if I move specific to the objectives of the current study, as I said, we'll compare two methods of CO attainments. One is student-wise, and as the second one is the cohort attainment framework, right? So this was a broad framework of the PO attainment. When I say PO, it's program outcomes. So program outcomes, as I said, it could be evaluated both by direct and indirect assessment tools. So you have, as a part of the direct attainment tools, you have external examinations or unit examinations, which you organize in time and time. There's different terminology across the institution. Some call it as unit examinations, some call it internal examinations. And there are further, you have assignments, quizzes, all the tools in place, which will be used as a direct assessment of the PO attainment, right? And there are several indirect tools as well. You have several surveys from all the stakeholders, and there are certain rubrics established for other activities which are in place at the institution. That is very specific to the institution. So as a final attainment, you have certain proportion in mix between direct and indirect attainments. You achieve total attainments, and you check whether you're able to reach the target which you have fixed based on the previous performance of the batches. If the target is able to reach, set higher targets is a way to move forward. If you are unable to achieve the set target, you have to look for where the gaps are and seek for an action plan for improvement, right? So this is a broad framework for your CO attainment. So CO attainments, COs are defined at course level, and you can choose any of the method. Here we are going to present two methods in specific. One is student-wise attainment, second is cohort-wise attainments. You can choose the tools of both direct and indirect. As we discussed, direct tools could be all the examinations and quizzes and assignments. Indirect tools could be course and survey. But in present calculation, we are going to present only the direct attainment process. Okay, so after choosing the tools, you have to map these tools to your course outcomes, and your assessment manual defined at program will actually give a guidelines of about how the levels of attainments are being defined. See, the levels of attainments in NBA program are characterized as 1, 2, and 3, right? So there are several criteria across various institutes, but most common practice of defining a criteria for levels of attainments is defining percentage of students, achieving a percentage of threshold. So department or the program would decide what would be the threshold, and also they try to decide upon what should be the percentage of students should be achieving a threshold and will be regarded as such and such level of attainment. So of course you will have a final attainment, then that should be compared with the target value based on the statistical data of the previous batch performance of the same course, in the same course, right? So if you are able to achieve the target, then set higher targets. If you're not able to achieve the target, find the reasons and try to improvise upon it. That is the strategy which we have. So these are the course outcomes for a course which we have as soil mechanics, and the Bloom's taxonomy levels were defined for course outcomes, and this is called, in NBA terminology, I should say, course articulation matrix. So which actually correlates between the CO statements and the program attributes, or the graduate attributes, uh, which were 12 graduate attributes here. Institutes also have program specific outcomes as well defined. They could range from 1 to 3. They typically range from 1 to 3. You can also map uh, to the program specific outcomes as well. So the idea of having a correlation matrix between COs and POs is, in order to attain PO attainments, we are actually initially trying to evaluate the outcomes or attainments at course level, and they are correlated to POs in such matrix. So through a weighted average approach, you further have certain calculations to attain POs, right? So here is the outline of the assessment tools which we have used and the way they are mapped to course outcomes. See, generally at our institute we define uh, uh, course outcomes around 6, and here is an example of such. So we have all the tools presented on the left, and their mapping with COs is given here. See, this is very important for us to have all the COs being assessed through all the tools, right? So if you look at as a big picture, this should give an idea that whether all the defined COs are being evaluated through the tools which you chose or not. So here it shows that all the COs are being covered through various tools, right? And you can choose a weightage among the tools which you chose, right? So out of all the tools, semester end examination is given greater advantage or greater weightage, I should say, and internal examination or unit examinations were given next weightage, and assignments and quizzes were given next weightage. And if you chose to have indirect approach as well incorporated into your CO attainment process through a course end survey, then you can choose further these two in proportion, right? But here we will reserve ourselves to understand only the direct attainments. So here is an idea we are trying to present. How do you calculate student-wise attainment? Okay, we are trying to talk about student-wise attainment. So all the questions which were part of examination were listed over here. Okay, and the questions were mapped against the COs. You can see the CO number has been represented here, and the marks scored by all the students across all the questions were also being in place here. So here there are some which were marked as not applicable. That is to signify that the part B of the questionnaire has certain choice. Students can choose which 2 questions they would like to answer, right? So they were marked as not applicable. So further, what we have done is, so for each CO, you have, each student will have what is the maximum mark which he is trying to write. See, this is you should appreciate that every student has his or her own unique way of addressing the question paper. So the composition of CO for a student might differ based on the questions he tries to address. So what we have done is we have tried calculating what are the maximum marks of the questions which we have, which he or she has attempted. Okay, so the maximum marks under all the COs were summed up and placed here, and then you checked upon what is the actual score he has done under certain CO, right? So here, if you try to take an example, if you want to attain see the attainment CO of CO4 of student 1 is nothing but how much he has scored. He has scored 1 mark for CO4. Out of the maximum marks is 2. So 1 by 2 is 50%. So that's how we are able to calculate the student-wise attainment, right? So this is similarly, you can calculate for CO5 as well as by taking a ratio of 10. Here you have 10 divided by 18 again. That should proportionate here as 56. Right? So that is how the CO attainments at student levels could be computed. Now, similarly, what we have done, we have calculated CO attainments of all the students, and we have listed out all of them together. And if you want to understand as a whole of the class, you can take an average of all these attainments throughout the vertical. Average of these attainments throughout the vertical. If you want to look at a class level or as a cohort level, right? So that is one approach. This is the second approach we'd like to present. Is this? So here again the same question-wise mapping, and their scores were being placed here. Wherever student has certain choice of presentation or addressing certain question, he has got not applicable written there. So what in this approach we have done is we are basically looking at this threshold has already been established as 60% at the program. And you try to check how many number of students who are trying to attempt such question. Okay, see, these questions have no choice. So all the students who have attempted should be the total strength who are attempting it. If you look at these questions, they don't have the complete strength in place, which means they are actually you have a choice-based system for those questions. So you looked at how many students who are attempting that question. And further, you looked at how many students have exceeded 60% of marks for that particular question. So these are the 60. These 8 students have exceeded 60% of maximum marks designated to this particular question, right? So now, in order to obtain what is the CO-wise attainment, what you have done, you have taken a ratio of 8 divided by 68. That will give you a percentage of 11.8. So that's how you're able to write. So for each question, you will have certain attainments, and each question attainment is mapped to certain CO. Say the questions 1 is mapped to CO3, question 2 is also mapped to CO3, question 3 is mapped to CO4, question 4 is mapped to CO3. So that's how you have distributed these attainments. And if you want to understand single value of CO3, you have got average of all these. Average, you have taken average in horizontal. So that's how you're able to have a cohort attainment. It means we are trying to understand the whole set of students as a whole, right? Instead of diving in deep at the student level. We have tried comparing those attainments which we have obtained through either approaches when we tried looking at student-wise attainments as well as cohort-wise attainments. We found that there is no substantial difference between the methodologies. But even then, why we have insisted upon student-level attainments is, as we spoke earlier, through a course articulation matrix, we'll be able to convert CO attainments into PO attainments, isn't it? So that is how, that is how we are trying to relate. When you try to calculate CO attainments at student level, each student will have his own unique proportion of these PO attainments as he or she progresses throughout the study of the course. So we are trying to understand how best we can group those students who are good at such POs, like PO1 to be engineering knowledge. So we tried devising certain strategy to students who are very good at engineering knowledge, to group them aside and try to give a special treatment or device specific training to them, right? PO 12 is lifelong learning abilities. So students who are really good at that are really fit for, we see they are very fit for research and higher studies. right? So we have tried proposing a way of, devising certain solutions or devising certain application of these PO attainments at student level. So these are all the proposed uh, uh, scope for placements. If you try to look at scope for placements, people who are good at engineering knowledge can actually be placed in core engineering companies. So we should have an idea that these set of students should actually be given certain training in addition to what they have to have very good placements in core companies. People who are good at problem analysis should be encouraged for higher education research laboratories. See, this deep down interpretations and as well as understanding of the students is not available with the conventional method when you look at a cohort level attainment. So we tried proposing a certain application for people who are good at such and such POs. So these are all the list which we propose. We have design people who are good at design and development can actually be placed in core disciplines. People who can conduct investigations can be placed in core discipline in design specific. So people who are good at usage of modern tools could be placed with software or IT industries or industries which tries to continuously develop new tools for the specific applications. Engineers and society, and they can be encouraged to join NGOs or public sector undertakings. And people who are good at environment and sustainability, there are certain NGOs who work for environment or certain core engineering departments which are working close to the environment sustainability. And people who are good at ethics, individual teamwork, or communication, they're all fit for every company. Every company desires for these things. So in fact, we can give this deep down understanding of each student to the recruiter to choose to present, or in fact, we can actually present these are the set of students who are very good at these things, right? So that's a major idea of going for a student-wise attainment rather a cohort-wise attainment. So in conclusion, we found that there is no substantial difference between cohort level and as well as student level. When you look at the whole class, look at the level of the whole class. But when you want to deep down into how good is the student in such and such PO, then student-wise attainment is a way to move forward to identify the strengths and weakness of students and devise necessary improvement strategies. Right? Thank you all for this opportunity. I also thank my co-author, Dr. Jayashree, for contributing to this paper.
Thank you so much, sir. Are there any questions?
2, 3 segment. Can I go?
Hello. Yes, sir. So could you please repeat?
Yeah, the first question is
Sure.
that you are mapping CO and PO.
Yes,
okay,
sir.
how you are giving the equal weightage of 3 to all the COs and POs?
So it's not 3 all the time. It depends on the level of relevance. So these this course articulation matrix could actually be composed of any values between 1, 2, and 3 based on the relevance. See, we also have COs which are mapped at level of 2. So it's a composition of how good the COs are very strongly related to. If they are very highly substantially related, we go for 3, and if they are marginally, we go for 2, and if they are very less or related, then we go for 1. If they are not at all related, we don't generally map them at all.
Yeah, for this example, you have given the soil mechanics, but you have mapped only for PO1 and PO2. Okay, so other than this, for soil mechanics, there is specific outcomes also we can create. Okay,
yes, sir.
PSO1, yes. PSO2, like that also we can
yes,
create.
That we have discussed. I couldn't present here.
Yeah. So that specific outcomes are there that you can use for the soil mechanics.
That's true, sir.
Okay, then next one is you are giving the weightage of 60% marks.
Yes,
Okay,
sir.
so
Yes,
you are, we can't give equal weightage for all the subjects.
yes, sir. That is true. In
But
fact,
compare-
various institutes adopt various set targets or the proportions. Be it like for design courses, they go for a different percentage of assessment, and for theoretical courses they go for a different percentage over there. But here we are trying to look at a policy which is devised at the institute. Generally, our institute has devised it this way, that external assessment will be of 60% and internal assessment will be a total of 40%. So that's how this weightages have been also.
Yeah, and one suggestion from me is, suppose
Sure.
if you are giving 60% of marks to soil mechanics, we
Sure.
can't attain. Okay, so subjects like soil mechanics, you can reduce the attainment level, and you can give more percentage for the subjects like construction planning, concrete technology, like that.
Sir, you're probably talking about the threshold value which we are trying to define.
Threshold value.
Yes, sir. Sir, thresholds are ideally should be established based on the previous performance of the students. But few of the institutes doesn't have this in place. They still follow a commonly adopted threshold across all the courses. So we took something in specific like that. Sir.
And after another thing, that indirect assessment 20%, how in what way you will attain?
Sir, generally, a course and survey is what we try to do, sir. Course and survey. So we try to take feedback on COs, CO1, CO2, or CO3. We try to take the opinion from the students that how do you feel that these COs are being addressed on a scale of be it 1 to 3 or 1 to 5, and they can be further brought down to a scale of 1 to 3. So you can choose any method over here, but most commonly, course and survey is the way people have been suggesting. So.
Okay. And the group of you need to take the group of students,
sure.
And you need to calculate the facilitation value, discrimination index. Okay, we can't make average of all the students. Okay, you need to select as a upper group and lower group people. Then only you can calculate this respective COs. Okay, class. Okay, then that is one more suggestion, because total you're taking average and putting this is not the thing. You have to take the groups.
Okay,
separate the upper groups, lower groups from the class strength, and then you have to calculate this attendance.
Okay, sir.
Okay, then good presentation. All the best.
Thank you, sir.
Thank you so much. And thank you so much for that presentation. You may now stop sharing your screen, and let's move on to our next presenter. Let's welcome Pushpak Dabade to present the maximization of hydropower releases from a dam considering environmental flow.
Hello, ma'am.
Hi, yes, I can hear you and I can see your screen. Go ahead, please proceed.
Okay, thank you, ma'am.
Oh, by the way, have it in presentation mode, please.
Yes. Is it visible now?
Yes, it is. Go ahead.
Okay. Thank you. Thank you for this opportunity. Myself, Pushpak Dabade. I am research scholar at Government Engineering College, Aurangabad, Maharashtra. And today I'm going to present my part of research work on maximization of hydropower releases from dam, considering the environmental flow. So this is about the abstract. The need of this particular subject is, as my research is on reservoir optimization. And what is reservoir optimization? As we know, the need of water is increasing day by day from all the sectors, and policymakers are under huge stress to provide that particular water releases to all the sectors. So optimization methods are nowadays more popular. And similarly, I am also trying for this optimal reservoir operation. This policy is presented considering the constraint, including all type of releases like irrigation releases, turbine releases for water, hydropower generation, reservoir storage, and hydrologic continuity. In this particular study, I am going to present a monthly reservoir operation model, which is developed using Python programming, and it is applied on Mazalgaon Reservoir constructed across Sindhafana River in Maharashtra state, India. Introduction. The rising water demand for all sectors present a challenge to policymakers to improve water allocation policies for storage reservoirs. Reservoir optimization methods are becoming more popular and suitable, which provides best feasible solution for water distribution among all stakeholders, considering all the constraints. So, in this particular study, a linear programming optimization method is adopted for optimization of single reservoir, that is Mazalgaon reservoir. And objective considered for this study is to maximize the hydropower release from that particular reservoir from the available storage. And monthly model is developed. For this from literature service, the lab they have presented a review on optimal operation model for a multi-reservoir system by all different methods of optimization for water resources, uh, operations and management. Then groups have discussed different reservoir system simulation and optimization model to give guideline about different methods and its usefulness in various types of decision support system. Again, Kim et al. Have developed a monthly operation rule for single reservoir operation for Canyon Dam basin in Korea. The objective for that study was to minimization of storage and maximization of sum of hydropower production. Geneton have suggested an interactive dynamic programming for optimization of reservoir operation to support the policymaker for balancing human and environmental water requirements. Similarly, Mosav et al. Have presented reservoir operation model using DP, that is dynamic programming, fuzzy rule based approach. And this model was applied to reservoir system in Iran. Nagesh Kumar et al. Have developed a reservoir operation model for flood control purpose with the help of folded dynamic programming. Then Regular and Anandraj have proposed multi-reservoir operation model using genetic algorithm under fuzzy environment, considering the multi-objectives. Also, Regular and Kamutkar have derived a fuzzy constant reservoir operation model for multi-purpose reservoir model is useful in dealing with imprecise constraints. Now, dealing with environmental flow, while providing water or release for different human demands, generally there is demand from environmental side, and that is going to affect largely because of less uh, availability of water in the rivers throughout the year. So environmental flow is required, or it should be released from every dam. So what is environmental flow basically? We can find a good definition from the Brisbane Declaration. The quantity, timing, and quality of water flows required to sustain fresh water and estuarine ecosystem and the human livelihoods and well-being that depend on these ecosystem. This declaration was formulated in 2007 in the International River Symposium and International Environmental Flows Conference, which is held in Brisbane, and around 800 delegates from different 15 countries were there in Australia. So from this, we can have a basic idea that what is environmental flow and why it is important to protect the environment. Now, in India, the Jain and Kumar have highlighted Indian scenario of environmental flow assessment with different Indian river case studies. Again, Lokirgar It will have discussed case study of Upper Ganga River and its cultural water requirement for environmental flow assessment. Similarly, SK Jain have discussed suggested adaptive management of environmental flow, which involves estimation of environmental flow requirements, consideration of those requirements in reservoir operation policies, and monitoring the results after implementation to revise the estimation. Now, as per the Indian scenario, the Indian summer monsoon typically lasts from June to September, and up to 90% of total annual precipitation we can have in this particular period. The southern and northwestern India receiving 50 to 75% of their total annual rainfall. Then this trend increases the tendency to store more and more water in the reservoir. As we know, the availability of water is going to be throughout the year, but rainfall or monsoon will last for only 4 to 5 months. So, which affect the availability of base flow in the river throughout the year. So, in most of the rivers, no flow condition observed during many days in the non-monsoon seasons also. Such situation degrade the river ecosystem badly and need a sustainable approach to make minimum flow available for all seasons. So there are some recommendations by Central Water Commission, that is CWC. CWC addressed this issue and carried out one study for environmental or minimum flows in various Indian rivers. As per his recommendation, CWC recommend there are two basic categories, that is recommendation for Himalayan rivers and for other rivers. For Himalayan rivers, it is suggested that the environmental flow or minimum flow must not be less than 2.5% of the 75% dependable annual flow expressed in cubic meters per second, and one flushing flow should be provided with a peak of not less than 250% of 75% dependable annual flow. For other rivers, which are other than Himalayan rivers, the minimum flow must not be less than 0.5% of the 75% dependable annual flow, and also one flushing flow should be there, which should not be less than 600% of the 75% dependable annual flow. The one notification from into October 2018 is published from for minimum environmental flow from Central Government of India. It is regarding the environmental flow requirement for Ganga River, and it suggests some rules for the projects which are on constructed on Ganga rivers, which are ongoing projects, as well as which are already constructed and operating projects. The requirement of environmental flow is applied to all the existing and under construction future projects. For the existing project, a period of 3 years is given to ensure minimum environmental flow, which are unable to meet the CWC norm at present. So after the brief literature review for present study of Mazalgaon Reservoir, it is observed that availability of inflow from river Sindhafana is insufficient. So the recommendation which is given by CWC, that is the one flushing flow should be released, and we should not be less than 600% of the 75% depending annual flow, is not feasible to adopt for that region. Hence, for present study, as per the CWC recommendations, condition of 0.5% of the 75% dependable annual flow is considered as a minimum environmental flow, and that is maintained for all the months. So, present study consists of Mazalgaon Dam, which is constructed across Sindhafana River at Mazalgaon district, Bid, in Maharashtra state. The catchment area is around 3,840 kilometers square. The command area is around 938.85 kilometers square. Gross storage capacity is 453.64 million meter cube, and live storage is 311.30 million meter cube. The length of right bank canal, which is provided for irrigation purpose in the command area, which is having length of 165 kilometer, with 1,31,520 hectares of gross command area. A canal hydropower project is installed on that particular project with the capacity of 2.25 megawatt. Mazelgaon Dam is a part of Jaikwadi Stage 2 project and also receives water from Jaikwadi Stage 1 project through feeder canal. So in model development, the objective considered for this study is to maximization of releases of hydropower generation. So there are so many releases considered while developing this particular model, like release for irrigation, release for hydropower, release for water supply, release for environmental flow. So objective is considered that maximize the total release of hydropower generation. And it is model is developed for monthly period basis. So maximize Z is equal to summation of T is equal to 1 to 12 release of power. The objective function is subject to some constraint, that is irrigation release constraint, turbine release constraint, constraint of reservoir storage, environmental flow release constraint, constraint of hydrological continuity. So irrigation release constraint are considered as like release for irrigation should be less than or equal to irrigation demand, and release for irrigation or should be greater than or equal to minimum irrigation demand. So there must be maximum irrigation demand and minimum irrigation demand, and minimum irrigation demand is considered as 70% less than the maximum irrigation demand. So turbine release capacity constraint, like release for power should be less than or equal to turbine capacity. Release for power should be greater than or equal to the firm power requirement from that particular project. Then constraint of reservoir storage, ST, or storage at that particular time period should be less than or equal to maximum storage, and storage at that particular time period should be equal to or greater than minimum storage. Then environmental constraint is considered as per the CWC recommendation, that is release for environmental should be greater than or equal to 0.5% of 75% dependable annual flow. Again, constraint of hydrological continuity is also considered with release from turbine, release for irrigation, a constant value of drinking water supply release, and release for environmental flow is taken. Storage of reservoir includes different losses from the reservoir, like loss due to evaporation for all months. Likewise, that particular hydrological continuity constraint is also added in the model. For this study, a monthly LP optimization model was developed with the objective of maximization of release for hydropower solved using Python programming. So LP model is developed with Python 3 and Perl library package is used for this particular model development. Now moving towards results. Now we can see here a monthly inflow is available for that particular reservoir. Similarly, minimum release of hydropower in million meter cube, that particular quantity is given. Then maximum release for hydropower, that quantity in million meter cube also is given. So after development, after a model, when I got results, it is found that release for hydropower in million meter cube is presented. Like for June, we can see the minimum release required for hydropower is 8.7 million meter cube, and maximum requirement is 29 million meter cube. But release provided for that particular month from our model is 9.32846, and simultaneously other releases also provided, like release for irrigation, that is 2.136 billion meter cube, release for environmental flow, which is calculated as per the CWC recommendation, so it is 0.16525, and that release is constant for all the months, while release for irrigation is changing as per the requirement of minimum and maximum irrigation requirement. But while achieving this, the objective is to maximize the release for hydropower. So you can see the maximum water is released for hydropower. So these are the monthly inflow versus demand graphs. In that you can find the inflow in million meter cube, maximum hydropower demand and maximum irrigation demand also. This is inflow versus releases, release for irrigation and release for hydropower. And these are the demand versus release for totally for hydropower project. So the maximum total annual demand of release of hydropower calculated on the basis of turbine capacity is 348 million meter cube. Minimum total annual demand for release for hydropower is estimated as per the firm power requirement of plant is 104.4 million meter cube. The total annual inflow recorded as 396.6 million meter cube. So, as the objective of the study is to maximize the release for hydropower, satisfying all the constraints of model provides optimum values of release for irrigation and hydropower generation. So, maximum hydropower release, which is obtained as 326.49 million meter cube, and annual release for irrigation is obtained as 204.37 million meter cube, and total annual environmental flow release is 1.983 million meter cube is released from reservoir to sustain the river ecosystem. So the conclusion is to develop model provides optimal monthly water release policy and increase the total release for hydropower. Simultaneously, because we considered here the release for environmental flow, which is not considered in existing case. So with this particular model, we ensure the health of river and ecosystem will be preserved by recommendation of environmental flow. So these are my references. Thank you.
Thank you so much. Questions?
Yeah, yes, ma'am. So I'm having two questions alone. Okay, so you have given this created the model using Python for all that is from 1 to 12. Okay,
Yes,
that is
sir.
the month from 1 to 12. The
Yes,
starting
sir.
month is June. Huh?
June. Yes, sir.
Okay, so from the month of June to 12. So what is the sources of how much quantity developed from each month? From where you have collected those sources?
Which sources, sir?
So you are giving the table.
Yes, this one.
Okay, flow na 20.98. Yeah, that inflow 20.98, 43.46.
Yes, that is inflow for that particular river.
Yeah, that data how you are collected from where you have collected those data, or you are just feed it?
No, sir. That data is actual data which is collected from Command Area Development Authority.
Okay.
Yes.
So that he has to mention here. Okay, as a source of thing. Then
yes.
Another thing, do you develop any prototype for a model? Develop any prototype?
Prototype means what, sir? I'm not getting actually.
Just a model with showing the things what you have done.
This actual physical model, sir?
Yeah, physical model.
No, sir. It is a totally mathematical model.
Okay.
Mathematical optimization.
So only mathematical relations that
yes.
Actually, it is optimization by using that condition.
It is just one part of my total research. Actually, I'm going to study multi-reservoir optimization model, which includes 4 reservoirs totally. So it is just a one part of my that particular research.
Okay. And your irrigation, the amount is meant to be reduced. No? For irrigation, the quantity of the water is reduced compared to the water which was supplied to the hydropower.
Yes, sir. Because objective is considered to maximize the release for hydropower.
Yeah,
if I change that particular objective, if I consider to maximize the irrigation release, So simultaneously, it will give maximum value towards this particular. But simultaneously, you can see the release for irrigation is 2.136. That is for June, which is
Yeah.
taken as minimum. Okay, but for all months, you can see it is always been in between minimum and maximum. That constant is given that irrigation really should not be less than minimum irrigation demand and should
Yeah.
not be greater than maximum irrigation demand.
Oh, what are the minimum standards you are following, right? Okay. 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 Good presentation. All the best.
Okay, thank you, sir.
Thank you so much. And thank thank you so much for that presentation. And now let's proceed with the third presentation. Let us welcome Vidya Shrikant to present the paper Project-Based Learning in the Architecture Design Studio as a Tool for Deep Learning, an ethnographic approach.
Thank you. Thank you so much.
Hi.
Hi. I'm Professor Vidya Shrikant. I'm from Day2 University, Bangalore. And my area of research is in architectural education. I'm deeply interested in the pedagogy of architectural education. And this paper is done in collaboration with my co-guides, Dr. Vibla Swami and Dr. Vikas Shinde. I'm trying to move the slide. Yeah. So just a brief introduction. That's me, and I'm been in the area of domain of academics for many years, and trying to bring in new methods of learning in architectural education. So basically, the research that I am doing is that the studio pedagogy is a large part of architectural education. And the method that we used is not working in the current scenario because the students are far removed from real world problems and finding real world solutions. So project-based learning has been tried very limited capacity in the domain of architectural education. So I have started my research on this topic of how we can bring in PBL into the architectural design studio. So the first part of my research was to look at peer-reviewed papers published in the broad themes, that is of curriculum design, how educational philosophies blend back into the philosophies of PBL, and the current ecosystem of education in India, especially because we are poised with the NEP and we are trying to find ways in which architectural education can go back to its roots of how things worked. And this led me to understand that there are gaps in the area of PBL and architecture education. So I want to establish that this method will help to achieve deep learning and reduce the gap between theory and practice. And the method that I've adopted is an ethnographic study because I myself am implementing the PBL model in the architectural design studio in the third year level at Reva University. And I am documenting the process and validating the results with a non-PBL method to see whether there is success in this method. So can PBL in architectural education overcome, this shift from teaching to learning? Can it be perceived as a method that brings in more active engagement in the process from the students? And will industry benefit by getting students who will be problem solvers using technology and tools? So this is the question that I want to answer. And to attain this, yes, I will use current peer-reviewed papers and to use recent quality published works to establish the background for pedagogical practices from ancient past to current times in Indian architectural education. So this is just a brief on the method that I have followed. I have followed the process of the PBL method and the non-PBL method and try to understand what are the parameters that drive the PBL method versus the non-PBL method. and document the instructional process of learnings and outcomes from the PBL method, and finally compare the scores with non-PBL and using both mixed methods. Of course, my research today, or the presentation today, mainly focuses on establishing a case for PBL in the architectural design studio, and I'm not delving into the actual experiment and the outcomes, which is going to be a content for a subsequent publication on the same topic. So I'm tracing here the chronology as to how PBL became popular as a method in first medical education, then engineering education, and finally it goes on to cover more domains as social studies, architecture, and various other fields. So we see that it is closely in sync with Dewey's theory of learning by doing, and also Piaget and Vygotsky's theory of experiential and social learning. So once this was established as a constructivist method, then Severy and Duffy recognize it as a tool, and it gains popularity. It is developed as a method across multiple disciplines, and then the Aalborg model and the McMaster model become prototypes for other universities to follow. And finally, we come to this success of PBL mostly in the 2006 to 2020 as a method in other varied disciplines. So this is what I want to say when we are looking at architectural education today. The way that the studio projects are set, they are in ideal scenarios. They are not real world scenarios. So this is if you were to look at a course like Design Studio, which becomes the foundation course for an architecture program, there are several other courses that support it, like building construction and materials, structures, building services, climatology, theory of design. All of this is there, but then they all don't feed back into the design studio. They're all a piecemeal approach, where each theory is each course is dealt with in a theory way, and the result is not seen in the architectural design studio. So rather what we can do is, if we are able to bring concurrent learning of all these subjects into the design studio, then it helps the students to think critically. They learn to collaborate and communicate with peers, which is one of the parameters of PBL. They become highly engaged in the learning process, and they are able to use all the three domains: the understanding, the questioning, the testing, and the application of the knowledge gained through these courses onto their design studio. Now, what does PBL aspire to achieve within the architectural studio? The three pillars of PBL, which is cognitive learning, content, and social learning. So all of this is very much possible in the domain of architectural education. And we feel that through the research that it can make the shift from teaching to learning. Students can benefit by being actively engaged with the teaching learning process, because the problem formulation itself comes from the student, and after identifying and doing a primary survey with the stakeholders, etc. And finally, industry will benefit by getting students who can solve real world problems. So this is what the research is all about. And here I wish to take you to the methods that used to exist in ancient Indian learning. When we look at Vedic learning and the Gurukul system, they had the system of Stuti, Smriti, Manana Shakti, and Nityasana, the four domains through which the students used to imbibe the knowledge. And if you look at the parallels in PBL, you can closely relate that to the same. So you have the self-study component, you have working in groups, you have the problem formulation itself, and demonstrating the knowledge through the real world example. So if we are to blend both this, then I identify through my research some parameters of deep learning, which is learning to transfer, critical thinking, communicating, not rote learning, motivation, joy, and purpose in learning, and demonstrating the learning. So if you draw these parameters of deep learning, then we can see whether PBL leads to deep learning. This is the the parameters of the non-PBL studio and the PBL studio. So if you look at the non-PBL studio pedagogy, the problem, whatever is the design problem, is defined by the faculty coordinators. And domain knowledge developed through special lectures is limited. The scale of the project is often very large, and individual response lacks deep understanding. And stakeholder feedback is ignored. Whereas in the PBL studio, if you are to achieve deep learning using the PBL parameters, you will find that students have greater control and ownership of the design challenge itself because they are involved in the project formulation. And real world problems are real world problems are given priority because the primary survey feeds into the design studio. And social learning happens because they're working in groups, and also you have scope for differentiated learning within the process. And the market trends are understood through diverse presentation modes deployed. So I will define each of these parameters and look at it into architectural learning. So we said learning to transfer, critical thinking, communicating, motivation, joy and purpose learning, and demonstrating the learning. So learning to transfer happens through the concurrent learning of all the relevant courses that feed into that particular design. Critical thinking will happen because in stages of literature studies and case studies and site, you will use your critical analysis skills to arrive at design solutions. And the communicating happens because of the presentation that you do through drawings, models, walkthroughs, brochures, and your motivation and joy and purpose in learning happens because you are solving problems that are very relatable to you, that are rooted in context and are very much a part of real world problems. And using your domain knowledge, you will demonstrate the learning to the facilitators. So this is the experiment was conducted across 2 semesters with 2 different studio projects. One was a housing project and one was a campus design project. And both PBL and non-PBL way in which it had been dealt was analyzed. But as I said, that is not the presentation today. Today is mostly about making a case for PBL. Going back. We say that the peer-reviewed published literature is limited, is very limited on PBL implemented in architectural schools, both in the Global West and the Global East, because it is still in its nascent stages of research. But PBL has to adapt to suit the Indian architectural education system because we work within the guidelines of the Council of Architecture. The curriculum is stipulated to some extent, but there is scope for flexibility. The theory of tying PBL to the ancient Vedic methods is still not explored enough, and this can become a unique contribution through our research. And there are similarities in its parameters to deep learning. So I hope to form a new taxonomy of learning through this correlating the ancient methods and the PBL methods. Assessment tools, especially for collaborative work in PBL, has not been widely researched. And within the domain of architecture, it will be a new knowledge. So the assessment tools is a challenge in PBL, especially when they work in groups. So formulation of rubrics and various other methods of evaluation can be explored further. And this will bring in a new domain of knowledge in this area. Training models for faculty in implementation of PBL in the architecture education is still not readily available. And I hope to formulate a PBL toolkit to disseminate the information and train more faculty to follow the PBL method. And the conclusions, the ethnographic research will hope to establish PBL as a process-oriented design studio. And this can be integrated into the curriculum easily. I also hope to achieve this course level implementation to a wider context, and it can probably be used to redesign the entire curriculum in India into the PBL method at a program level instead of not remaining just at a course level. Assessment methods for collaborative work will be a new outcome, and evaluation parameters will be in accordance with PBL method in terms of reports, facilitator, rubric assessment, juries, reflective journals, etc. And a new taxonomy may develop based on indicators of deep learning that relates ancient Vedic methods to project-based learning. And finally, I hope to achieve that and prove that it will reduce the gap between theory and practice and promote deep learning. And this will lead to a more active, experiential, and inquiry-based architectural education in India. So this is my method that I used, inclusions, exclusions of the review, literature reviewed, and the broad themes. Some of the main ones are elaborated here on the theme of education, curriculum design, and architecture. There were about 12 reviewed papers. And learning methods and models to understand PBL models in other disciplines. I did a lot of reading. And how culture affects PBL. This is also important, especially when I'm trying to implement it in the Indian scenario. So a lot of papers help me understand that it is important to take cognizance that at the undergraduate level, there is the experience of self-learning is very limited, and this will have to be overcome. Finally, yeah, some of the readings through other courses like structural engineering, where they feel that architectural studio pedagogy has certain aspects that kind of suit very well to project-based learning. So this also helped me to a large extent. So that's my presentation. Basically making a case for architectural education and hoping to complete and continue my journey in this domain to complete my doctoral thesis in this topic. So I thank you and welcome questions and leads on how I can further my research.
Thank you so much. Are there any questions?
It's a good presentation, Professor Vishwaniketan. Ma'am, I'm having one small question that whether you have tried any practically by taking some group of students and you tried this pedagogy that project-based learning?
Yes, sir. Over 2 semesters, I have tried it with 2 different cohort groups. One we gave a PBL method and the other we gave a non-PBL. And I have also compared it with past batches, which were all obviously in the non-PBL method. And definitely there is a shift in the grades, in the sense the entire class, the parameter has moved upward. And through qualitative surveys and understanding also, I've received that the deeper learning has started with PBL because they are able to bring in the knowledge of other subjects and also the knowledge gained by working through peer groups into their understanding. So definitely it is showing me good results, and I hope to replicate it in other universities by training the faculty coordinators and seeing whether the environment has an effect or it will work across different environments.
Okay.
I'll stop sharing.
Yes, please. Thank you so much for that presentation. And I would like to take this opportunity to thank our session chair for the technical session 3. Thank you so much, Mr. M. Subash. And now we'll proceed to our valedictory session. To give the vote of thanks, let us welcome Assistant Professor. Sorry. Hi. Let us welcome to give the vote of thanks, Assistant Professor Kishore Mani to deliver the vote of thanks.
Ma'am, I think the vote of thanks and valedictory function is scheduled at 1:30.
Yes.
It is scheduled at 1:30.
Hold on.
We should wait for the presentations to
Oh,
over in room 1 and room 2.
yes. I still have room to finish. Please stand by. Hello, everyone. So our technical sessions 3A and 3B is already done. And all the participants are requested to go back in this main room. And now we will have a short break for the deliberation and we will proceed with the valedictory after the break. Everyone, please be back at 1:30 sharp India time.
डबा नाही माझा, मी तिकडेच जेवणार ना मी. सरांचा डबा कुठे आहे?
Welcome back, guys. Hello, everyone. Good afternoon to one and all. And I would like to welcome again our Honorable Vice Principal, Professor Shankar Kadam, Vishwaniketan Institute's Management, Entrepreneurship, and Engineering Technology for valedictory session of the International Conference in Innovation Challenges and Advances in Engineering and Technology. A Road to Self-Reliant India, or the ICAET 2021. This is organized by the Department of Mechanical Engineering, Vishwaniketan's Institute of Management, Entrepreneurship, and Engineering Technology, or the VMET, in association of, again, yours truly, the Institute for Engineering Research and Publication. Now, for the awardees, I have all the awards here from day 1 up to now, day 2, of all the presentations. Again, everyone, congratulations. For technical session 1 yesterday, best presentation award won by paper title, Experimental Investigation of Cylindrical Imbibed Pad Evaporative Cooler by Mr. Kishore Mani. Best Research Paper Award won by Analysis of Flow and Heat Transfer Enhancement of Turmeric Cooking Steam Generator. Was presented by Mr. Randir Chavan. For technical session 1A yesterday, Best Presentation Award won by Industry 4.0, Enabled Sustainable Supply Chain, presented by Pankaj Shilar. And another best presentation goes to Performance Modeling of Process Heater Design using Digital Twin Technology, presented by Mr. Sanket Chudari. For the Best Research Paper Award won by Study of Forming Limit Diagram and its use in practical application by Aditya Kakad. Also, another awardee, Best Research Paper Award, goes to Modeling the Barriers for Lean Implementation in Healthcare Supply Chain Management by Mangesh Ahire. Now, for technical session 1B yesterday, Best Presentation Award won by Review on Issues Related to Modeling Industry 4.0, Enabled Sustainable Supply Chain for Micro, Small, Medium Enterprises in India, presented by Professor Sagar Dutare. And another Best Presentation Award goes to Product Development, Perspective of Lean Six Sigma and Industry 4.0, presented by Sainath Bidikar. For the technical session 1B, Best Research Paper Award goes to Design of Active Suspension System for Quarter Car Modeling User Linear Quadratic Regulator, presented by Shailesh Rawul. For technical session 2A, again from yesterday, Best Presentation Award goes to Review of Harmonic Mitigation Techniques for Power Quality Improvement in Distribution Network, presented by Pranita Chavan. And for Best Research Paper Award goes to a review of articles representing renogram processing techniques presented by Pradnya Gokali. And for today's awards, for technical session 3, Best Presentation goes to Project-Based Learning in the Architecture Design Studio as a Tool of Deep Learning, an Ethnographic Approach, presented by Vidya Shrikant. Congratulations. And for technical session 3A, hosted by Divine, Best Presentation Award goes to Hand Assistive Device for Deaf and Dumb, presented by Priyanka D. And for the best research paper goes to Model Predictive Controller in an Autonomous Vehicle, presented by Abhishek. For technical session 3B, hosted by Gretchen, Best Presentation Award won by Reformulation and Restrategizing TVET Policy in Nigeria's Education System, Suggestive Induction of Innovation in Entrepreneurial Education Characteristics, Adoption of Ex Post Evaluation Review Method, was presented by Ikin Francis Okagbe. And for the Best Research Paper Award goes to a co-additive nanoemulsion using tretinoin and curcumin formulation and characterization, presented by Parmita Fogat. Congratulations to all the winners. And of course, congratulations to all the presenters. For the certificates, by the way, and proceedings will be sent to you, all the participants, and the awards will be sent to you via email within 48 working hours. And now let's move on to deliver the vote of thanks. Let us welcome Assistant Professor Kishore Mane.
Yes.
Hi, sir. Good afternoon.
Good afternoon, all. Honorable Dr. S.S. Inamda, Vice President Vishwaniketan, Dr. B.R. Patil, Principal Vishwaniketan, Dr. Vikas Shinde, Director, PBL Center of Excellence, Professor S.B. Kadam, Vice Principal Vishwaniketan, Professor Bhavesh Pasi, HOD Mechanical, and heads of all the department, and most valued invited speakers along with Team IFERP. It's my privilege and honor to have been asked to propose a vote of thanks on this occasion of Virtual International Conference on Advances in Engineering and Technology, a Road to Self-Reliant India, ICAET 2021. Myself, Kishore Mane, convener of this conference, and on behalf of Vishwaniketan, extend a very heartfelt gratitude to all the participants and keynote speakers for gracing your important work and sharing with us your important findings and opinions during the 2 days. I take this opportunity to extend my most sincere thanks to the steering committee chairs and steering committee members from engineering colleges across India. I must mention my deep sense of appreciation towards the organizing committee of this conference and IFERP coordinators for their meticulous planning and execution in organizing the great event despite the pandemic. Once again, I want to mention that Vishwaniketan is grateful to all the delegates who contributed to the conference positively. It's been a great pleasure. Thank you very much.
Thank you so much, Professor. And now let us welcome our very own founder and managing director of Technorit Group to share a vote of thanks. Let us welcome Mr. Sid Kumar.
Thank you, Jojo.
Hi, sir.
Hi. On behalf of IFERP and VIMWT, it has been my immense pleasure to thank all the speakers, committee members, session chairs, delegates, and participants of the International Conference on Innovation Challenges and Advances in Engineering and Technology, a road to self-reliant India, organized by Department of Mechanical Engineering, Vishwaniketan Institute of Management, Entrepreneurship, and Engineering Technology, Maharashtra, and Institute for Engineering Research and Publication. The participants were very enthusiastic. We have been fortunate to have some of the eminent persons from academia. I am sure that the participants must have benefits by attending the conferences. I am thankful to all the participants of the conferences for their presence even on this pandemic situation. I am very much thankful to the eminent delegates from VIMWT who helped in making this conference a grand success. I sincere thanks our chief patron, Dr. Ramji Prasad, Honorable President, Aru University, Denmark. Dr. S.S. Inamdar, Vice President, Vishwaniketan, Institute of Management, Entrepreneurship and Engineering and Technology, Maharashtra. And patron Dr. B.R. Patil, Principal, VIMEET in Maharashtra. My special thanks to our keynote speaker, HE UNESCO laureate Professor Sir Bashiru Arimo, the Vice Chancellor, Crown University and International Chartered INC, USA. The partner Constitutional Campus Drive, worldwide, Professor Dr. Dilip Kumar, Director of Professor NFCT Malaysia and Professor Vice Chancellor Academic and Research, GNS University, India. Dr. Andemulli Varaprasad, Professor and Director, CIGS, Saint and Engineering College, Chirala, ex-DRDO scientist. Dr. Mahdi Karkush, Professor of Civil Geotechnical Engineering, University of Baghdad, President of Iraqi Geotechnological Society, Iraq, and Dr. Santosh Rane, Dean Academics, Sardar Patel College of Engineering, Mumbai. I am thankful to our steering committee chairman, Dr. Vikas Shinde, Director PBL COE, VIMEET Maharashtra, Professor Shankar B. Kadam, Vice Principal, VIMEET Maharashtra, and Professor Bhavesh Kumar N. Pasi, HOD Mechanical Engineering Department, VIMEET Maharashtra. I take this opportunity to thank all the session chairs, conveners, steering committee chair, or organizing committee members, national and international advisory committee members, reviewers, and technical committee members for their valuable suggestions and provided their valuable comments in time and help toward the improvement of quality of papers present in the conferences. I thank all the speakers and the delegates for their enthusiastic participation in this conference. I am sure that the participants must have benefited by attending this conference. Finally, I acknowledge the unwavering support received from Vishwaniketan Institute and IFERP staff members. My thanks all also go to the people who have given their precious time in organizing their valuable conferences and made this conference successful. On our part, we have also made sincere effort to enhance the quality of the conference by publishing all the extended version of papers in Scopus Index Journal. Thank you very much.
Thank you so much, sir. And now I hope everyone, inclusive of your family members, are safe and doing well at this COVID pandemic. First of all, I congratulate you all for your active participation and successful conduction of this program. I am grateful to our Vishwaniketan's Institute of Management, Entrepreneurship, and Engineering Technology dignitaries, Principal Dr. B.R. Patil, Vice Principal Professor Shankar Kadam, and our Mr. Rudra Banu Satpathy, CEO, Mr. Sid Kumar, Founder and Managing Director, Technorit Group, and our eminent keynote speakers, HE UNESCO laureate, Professor Sir Bashiru Arimo, Professor Dr. Dilip Kumar, Dr. Madi Karkush, Dr. Santosh Rani, Dr. Andy Murali Varaprasad, and technical session chairs for sparing your valuable time and words of wisdom with us. I take this opportunity to express my warm gratitude to Professor Kishore Mani, Professor Chinmay Rohikar, Professor Sagar Dutari, and IFERP team for their sincere support and cooperation. I thank all our ICAET 2021 organizing committee members for their efforts, and I express my gratitude to all the participants. Congratulations once again. And I would like to request everyone to stand for the national anthem.
जनगण मन अधिनायक जय हे भारत भाग्य में पंजाब सिंध गुजरात मराठी उत्कल बंग विंध्य हिमाचल यमुना गंगा जलधि तरंग तव शुभ नामे जागे शुभ आशीष माहे गाहे तव जय गाथा जनगण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे।
Thank you so much, everyone. Thank you again. And certificates and proceedings will be sent to the participants' email within 48 working hours. Thank you so much, everyone, for your participation, cooperation for this conference success. See you all next conferences. Once again, your host, Jojo. Bye.
Bye.
Bye-bye. Thank you. Thank you, everyone.
Thank you all.
We learned a lot.
Thank you, everyone, for active
Thank you
participation
so much.
and showing interest in this international conference. Thank you very much.